Look at CSS because we're not trying to be web app developers. I'm not going to spend a lot of time on CSS, just going to give you a quick overview so that you know what it is, and when you see it you'll be able to recognize it and know that it really isn't anything important to you unless you are crazy good and you can pull off some kind of remote code execution through a CSS injection, which can happen but is really advanced. So we're going to just look at some simple basic CSS so that you are aware of what it is and you aren't questioning when you see it inside of some source code. I'll see you in the next video. All right, we're going to have a look at some CSS. We're not going to spend a ton of time working on our little website here, making it look nice. For me, I am not a designer and I don't understand web design and fashion or anything like that, or color coordinating. So in the world of web development, this is, for me, the most difficult part, is making a website look nice. Some people are just gifted as designers and I am not one of them. So I'm just going to show you how CSS works in two different ways. I'm going to show you internal CSS and I'm going to show you external CSS. So that way when you come across CSS, you know what you are looking at and you're familiar with it. I'm not going to actually show you how to design a web app because that is not my area of expertise and it's not my gifting. If we want to do some internal styling, we can just come in here and type in style and we can hit enter, and then we have this H1 right here that has our name in it, so we could just very easily just type in H1 and then we open a set of curly braces and then we can just type in color and then we can just type in aqua. Looks like a great color, and then we close it off with our little colon there and we save it and we come over and refresh our page. I see I didn't type in H1, typed in HR, so we type in our H1, save it, refresh, and our color changes to blue. And then maybe we want to change the word right here, hacker. There's another way you can go around doing internal styling, and you can just come in here and say that you want a color, and then we say we want pink, and then we can save it this way, and then if we refresh it, our color works. So there's several different ways you're going to see internal CSS, and this right here is the most common. This happens, but it doesn't happen very often. So when you're out in the wild, you will see CSS function like this, and you can also do a lot more with this. We're not going to cover it, so you could come in here to this H1 and you could type in something like padding, and you can say padding left, and then we could say like 200 pixels, and then if we were to save this and come back over and refresh it, you'll see that the name moved. I'm not sure if there is a centered option. Let's check it out. There is not. So there's something called Bootstraps that would really help you with your styling if you were trying to become an actual developer, but we're not going to spend a ton of time with that. So you can do things like the padding left. You could do a padding for the bottom if we wanted some space between our information here, and you could say 100 pixels, and you could save this, and if you came over here and refresh it, we'll get a padding over here. So this is a little bit of styling, and one thing to be familiar with is a lot of times things are going to be broken up into divs. So you would have something like this right here, you would have a div, and we'll just copy this and cut, and we can paste that right here. And then we'll put another one, we'll put this right here, and then we'll put one down here between our list that we have right here. And then if we were to put something inside of here, like we say this div, we want to style it, and we say style, and then we want color, and then we're going to make this entire color red. It's going to be very bold, and then we decided to make a different div, and we wanted the entire color to be, let's say we'll make this entire color pink, and we save this and we refresh our page. You're going to see that everything within those divs actually changes colors, except this overwrites what was written inside the div. So we can actually just go ahead and close this out right here. And now if we come back and refresh, you can see everything becomes red and pink within the specific div. And so this is an introduction to internal CSS. You can style it either up here like this, or you can do some internal CSS. And so the divs are going to be like, you can, within HTML and CSS, you can think of everything as being inside little boxes, and there's actually a Chrome extension. It'll actually show you all of the boxes, and it's called Pesticide, and you can install it if you want. I'm not going to show it because the point of our course is not to learn how to be designers. The point is for us to understand CSS well enough to know what we're looking at so that we can figure out how we can exploit web applications when we come across it. So with that, in the next video we're going to look at external CSS. Okay, in this video we're going to look at an external style sheet, and then I'm going to show you why this was important for you to learn. So the first thing we're going to do is we can just go ahead and delete these inline styles that we put in right here, so that way we have our blank page like we did before. And we can just go ahead and delete the style altogether, and then if we save this and go back to our page and refresh, everything is back to how it was before. Now what we are going to do is come right here, and we're going to add a folder just like this, and we're going to call it CSS. And then inside this folder we're going to add a new page, and we're going to call it style.css. And you can see our Visual Studio has recognized it as a style sheet. Come back to our index.html, and inside of the head tag up here we can type in link, and it tells us that it has this style sheet, and we have the href2, and we want to link our CSS style sheet just like this, and it auto saved for us, and we can now save it. And now you can come over to your style sheet, and if we wanted to do like we did before, we can type in the h1, and we can type in color, and we can say red. And if we save this and come back over to our page and refresh this, our name is now red because that was the h1. We can do something like we did before with these divs, and we can say we want to give the div a color. So we could say div1, we want to have a color of blue, so we can come in here, we put our period before the div, and this is going to tell it that this is going to be our keyword, and we can say color, and we want blue just like this, and then we'll make a div2, so we'll say period div2, I forgot this was div1, and we can say we want the color of pink. We'll go div1 right here, and we can say style div1, and I just realized that this is supposed to say class because we've given it a class name over here. And then if we give our second div a class of div2, and we save this and we come over here and refresh it, we now have the colors have changed within our div, and our name color has changed. So this would be a form of external CSS, and I want to show you why it was important for you to know this. And it's important to know that this file was named CSS, and then we called it style.css. If we come back over here and we just check out this color palette and we inspect the page, and then you come over here to the sources, you can actually click on this CSS right here. Yours might not be all in line like this. You can click on the CSS, click on the style page, and then click the pretty right here to make it look pretty. And you can see just like this what they have done. It is organized just like ours. So this would be an anchor tag, which would be clickable, and they have red, green, blue, not sure what the A is, and then they have the text decoration, none. And so you can see their style sheet is called CSS just like ours, and style.css, and then it is formatted exactly the same way, and this would be an external style sheet. And then if you come back to looking at the elements, you can see the class right here, the class names for how they decided to name their classes and organize what they look like based on the CSS. So now when you come in here and you inspect a page and you come across a CSS file, you'll know what you're looking at, and you'll also be familiar with seeing class inside of the divs. seeing these class names. And that is going to wrap up for us the CSS internal and external. I will see you in the next video. Okay, we're going to be moving into a section on JavaScript. And so as we go through JavaScript, it will be helpful for you to have a great place to practice your JavaScript. And a really easy place to practice JavaScript is within the Chrome developer tools. So I would suggest, if you do not have Chrome installed, go ahead and install Chrome, because we're going to be using it throughout the portion of our JavaScript course. So an easy way to practice JavaScript is just come over to your web app that we have running within Chrome. We can go to inspect, and then we will go to sources. You are going to be on this page right here. We're going to hit these two arrows right here, and we're going to say snippets, and then we'll say new snippet, and then you can just call this index.js, which is the file name within your code that you would have it named over here. And then you can actually just type in your JavaScript right over here, and then when you're done, you can run it just like this by hitting play, and it'll hit up an alert for us. And then if we want to do something like a console.log, and then we want to log something, it will actually pop open the console for us right down here, and it will tell us what we have logged. So this is going to become more familiar with you as we are going along. But this is where we're going to be practicing our JavaScript. And if you're unfamiliar with JavaScript entirely, JavaScript is the scripting language of the internet. So if you were wanting to become a web application penetration tester or a bug bounty hunter, JavaScript is going to be something you're going to want to learn, because it is the language of the internet. It is what gives websites functionality. So when you go to a web application and you see things moving around and stuff happening, that is going to be thanks to JavaScript. So JavaScript is going to be very important for us to learn, and we're going to spend quite a significant amount of time learning this JavaScript. And so buckle up and get ready for JavaScript. One thing that is important to know about JavaScript and really any scripting language is syntax. So you saw me type in alert just like this, and then we can type in the word hello. And then if we close this off, this is not going to work for us. We're actually going to get an error, and if we open up our console, it tells us that we have an error right here. The reason is because these characters within this alert need to be within side quotations, because this is considered a string. So JavaScript wants to interpret whatever's inside of here either as integers, such as 1, 2, 3, and this will run for us and it will work because these are integers, or you're going to need to have strings inside here. So if we type in some characters, we will need them inside of a string. And now if we run this, it will work for us. So we have this alert right here. What is this alert? This alert is calling a function within a JavaScript, and in the future we're going to make our own custom functions. But for now, all you need to know is this alert is a function, and it is going to pop up the string of characters that are put within here that are being passed within the function. And then I believe we need this within Chrome Developer Tools to close off our alert, and I guess we do not. But typically when you close something off, you will close it off with a semicolon just like this. So it's best practice to go ahead and start putting it in there now as we are practicing. So with that, I will see you in the next lesson. Before we make it too far into our JavaScript lesson, I think it's helpful to know there are several different types of data types, and we've already saw this one right here with a string. But if we pull open the console here, which is really great, it is going to be a very useful tool to us as we're learning our JavaScript. We can type in something called type of, just like this, and then we can put whatever we want inside of our brackets right here, and we can say we want to put in 1, 2, 3, and it tells us this is a number. And if we put in a string right here like this, we don't even have to type anything in, and it tells us this is a string. And then we also have one other type of data type that will be really helpful to us, especially when we're we're running while loops, and that is true, false. And it will tell us this is a Boolean. So you have strings, integers, and Booleans, and we're going to be using all of these as we move into our JavaScript, and it will be helpful for you to remember these. You're also going to see these within different exploit write-ups within the world of hacking, and so it's important to know that you have integers, strings, and Booleans, because you will come across these in the future. And if you ever do any kind of programming, or you're writing up the code for your own exploits or modifying exploits, you will need to know what is going on and what kind of data types you are dealing with. So with that, there is one more area of JavaScript that I want to cover before we start trying to write any kind of code or do any kind of exercises, and that is variables. So with that, we will check those out in the next video. Okay, so here we are with our variables, and there's a couple different ways I want to show you how to use variables. The very first thing I want to tell you about variables is that it stores some information for you. A variable is going to store some kind of data that we can later come back and say we want this variable, what information is within it, and it will tell us the information that is in it. So for example, if I say var equals 2 plus 3, and then we have to name our variable, and we'll just call it num. So we have this var num equals 2 plus 3. We need to close off our JavaScript here. 2 plus 3. There we go. Get rid of that error. And if we run this, it's going to tell us that we have nothing happening because we need to console log this. So we go console.log, and we're going to log the number. So this is our variable being passed through the console log function, and if we run this, we get the number 5 down here. So this number contains the information 2 plus 3, which is going to be 5, and the console.log just prints the variable down here for us. So we have this right here, and when we run it, we get our number. But how can we take information from the user and use it? There is a function called the prompt, and if you're very familiar with cross-site scripting at this point, then you have for sure seen this in cross-site scripting payloads. A prompt is also another way to view a cross-site scripting instead of an alert. And so you can say prompt, and then we can pass in our information here that we want, and we can say what is your name, question mark, and we can close this off. And if we run this, it should give us this little alert here, and we can say Ryan, okay, and then it prints down here for us. But how do we get this information that we put in here? We need a variable. So if you want, you can go ahead and pause this video and see if you can figure out how to store this prompt in a variable called name, and then get it to console log down here what our name is, or the information that we put into the prompt. And you can go ahead and give this a try now. Okay, this is a pretty simple challenge. All we're going to do is change this to a var name equals what is being put in the prompt, and then if we come down here, we can console.log, and then we'll put up our brackets, and we'll say name, just like this. And now if we run this, we're going to get a prompt, and this time we're going to say Ryan J, okay, and it prints out for us Ryan J down here for us through our console log. I'm actually not entirely sure if it will print anything. If we don't put the console log, it does not. So the console log is necessary to be here for our name to be printed. So we can try this again, and we say name, and it prints name for us. Now there is another way to go about this without the console log, and we could type in like our cross-site scripting that we are familiar with, and we can say hello, and then we can pass in the name function. So we should be able to type in hello plus name, and if we run this and we say Ryan, we get an alert saying hello Ryan. So this is how an alert would work with a console log. The space has to be put right here. That was my problem on why I couldn't get that to space. So we just say like that, hello space, and then name. And so now it should alert hello Ryan, just like that. Okay, so you just need this space in here to get the space in the alert. So this is a variable and a prompt. And so I want you to get used to looking at these types of variables and information. So just go ahead and play around and maybe do some simple math, store it in a variable, display it in an alert, maybe do a couple console logs. Before going on to the next video, so that way you're familiar with variables and how they work. Okay, so in this video we're going to cover the while loop, and in the next video we're going to cover the for loop. And I decided to start with the while loop because it is quite a bit easier to understand, and we're going to just make a simple while loop, and we're going to count to 100. So we can say I equals 0, and then we'll say while I is less than or equal to 100, we want it to do something, and we want to console log I, so we'll go console log, and then we'll say I, so that way it prints the I for us. And the next part is very important. We'll say I plus plus, and this will add 1 to I every time. So the first time it runs, it'll be 0, 1, 2, 3, 4, and so on until it reaches 100, and then it will stop. If you do not have the I++, you'll probably freeze your computer and have to force restart. So this is very important. And so we can go ahead and run this, and it prints out for us that we have all of the numbers here for us, starting with 0. And so this is the while loop. It runs a function or whatever is inside of the while loop until it has reached the total destination. And sometimes you can have a while loop running with taking user input, and when the user input says to quit, you can shut the while loop off. But we're not going to go into that because I don't think it's something you need to know in order to be an ethical hacker. And with that, we will move into the for loop. Okay, so the for loop is going to look a little more daunting and scary, but it really isn't once you understand how for loops work. So if you're coming from another programming languages, for loops are really simple, but in JavaScript, they're a little more difficult because JavaScript is the language of the web. It's not made to run for loops in a simple manner like Python. So if we run a for loop and we're just going to run a simple counter like we just saw, we can say something like for, and it's going to ask us, do we want to run a for loop? And we're going to say yes, and it gives us the boilerplate for a for loop. So we'll just leave this index instead of I, and so we're just going to say that I equals 0, and as long as it is less than 100, we're going to go ahead and say I, or index in this case, plus plus, and then we can just console log this. And then we'll say index just like this. And now if we run this, we're going to get an output down here of counting to a specific number. So in the world of programming, I almost always use for loops. I rarely use while loops, but I just wanted you to see these for loops and while loops so that you can read them when you're looking through JavaScript code for vulnerabilities. So I just want to show you how to enumerate APIs, because this is something that isn't covered in any courses or any certifications that I know of. So if you come in to your terminal and you have an API like this, and you come in here and you type in like V1, or you're typing in basically anything, you're just trying to figure out how do you get further down the line, you're just looking for endpoints. The tool I like to use for API fuzzing is Fuff. So it looks just like this. If I can get here, Fuff, there we go. And I actually ran this just to make sure it was going to work before I did the video. So I like to run Fuff, and then you give it the URL, and this is the API, and then we're going to be fuzzing for an endpoint, and then you give it a word list that you want to use. GoBuster and Derb and a lot of those your usual fuzzing tools just don't work with APIs. So I like Fuff because it does work. And you run this, and you see it pulls down docs and API. So if you were to do this like in a live program, you'd come in here and you just type in API, and then it says we have V1. So you can just type in V1, and then you'll have user, and you can kind of see if we wanted to look for more endpoints, we could just close out of this and we would just move our fuzzer over. So you would just go like this, and then it would fuzz right here, and it would look for more endpoints over on this point. So that's how this fuzzing APIs work. If you're interested, you can go ahead and do the box, hack the box. It's actually really simple. You just create a username using the API. So you'll use burp, you'll just intercept the request, and it'll send you back a JSON of what you need, and then you can turn your request into a post request and make a username and password and log in. So this is API fuzzing. You'll see these on bug bounty programs, and sometimes you'll come across them in hack the box machines, but this is something that's not really covered, so I wanted to make a quick video on API fuzzing and bug bounty. So sometimes you can find an API URL like this, and you can just start fuzzing away and see what information you can come back with and manipulating the request. So that is API fuzzing. We're going to cover server-side request forgery. The purpose of this video is to show you what is going on inside of server-side request forgery and walk through a couple of examples so maybe you can understand what is happening. So the way we're going to go about this is I'm going to show you a flowchart, and the flowchart might not make a whole lot of sense in the beginning, but I want to show it to you so that way you kind of see what is happening. And then we're going to walk through two different examples and then come back to the flowchart, and at that point the server-side request forgery should make a lot of sense to you, and you should be able to start looking for these bugs as you are browsing through programs, and you'll be able to submit a proof of concept that makes sense to the person who receives your bug report. With that, let's jump into it. Or with a very simple basic flowchart. I tried to make it as simple as possible so that you guys could understand exactly what's going on and that it wouldn't be too busy with too much going on. So this would be us, the user, and you could also change this to the hacker or the attacker. And so the attacker sends a URL request to the website. So we're manipulating the URL, and then the website makes this request that you weren't supposed to be able to make to the server. And then the server sends the data back to the website, and then you can view it as the attacker. So this is how the flow works. If you were just a regular user, we would just have user here, and you'd send a request, and it's just as any request that's going to the website, and the website would pull the information from the server, and the data would be sent back to the website, and you would see the request that the website made to the server. The problem with the server-side request forgery comes in when you have the ability to manipulate this URL request. So let's say it's the URL wants to reach back to the home or root directory, and you're able to grab a file off of the server instead of the actual directory right here. So with that, we're going to go ahead and move into an example. So we are going to be using this example from Love on Hack the Box. I'm not going to walk through all of the recon and what gets you to this point, but rather just what is going on with the URL. So in here we have the web application that's going to reach out to the server through this URL form right here. And if you're ever doing a CTF or any kind of certification and you see something like this, this is a dead giveaway that there is a server-side request forgery anytime you see a URL right here. But most of the time the URL is going to look like this up here, and you're going to have something like this, and then it will pass in a parameter like a URL equals, and then it'll have a file right here such as the root directory or some kind of file. So we could just put in here some file, and then what you would do is you would manipulate this right here, and you could pull down files a different way, but instead of having it right here inside of the URL, this web application has it right here. And because this is an easy box on Hack the Box, that's probably the reason they put the URL request down here in a submit format instead of being in the URL, and you have to deal with it inside of Burp. So this is how you're normally going to see it. It'll be up here in the URL, something like this. And in the next example we're going to see, it's also not going to be up here, but it's going to submit a URL request, and we'll be able to see it in Burp, and we'll be able to manipulate it just like we would up here, only we're going to do it in Burp. So inside of this file scanner right here on this Hack the Box, if you ever want to test a server-side request forgery, it's pretty simple. You can just come over here to a terminal, and you can set up a Netcat listener on port 80, and it needs to be on port 80 because it's going to have to go through the HTTP protocol. Over here, you would just type in something like HTTP right here. This is my VPN with Hack the Box, and so we can hit scan file. It's going to hang for a second, we can cancel it, or you can just come over here and cancel out of this. You can see that it reached out to my little Netcat listener here on port 80, and so we know that this is trying to grab a URL, and you can check to see if it's grabbing a file from the server by typing in the actual IP address. So in this case, for this Hack the Box, the IP address is http / and it's 10.10.10.239, just like this. And if we scan this, it's actually going to bring back the web page right here. So if we went to this IP address right here, we said http, and then we said 10.10.10 239, and then we come here, you'll see this voting system right here. This is also on this server, so I actually had to add this to the Etsy host file, and if you're not familiar with that, what that is, that's okay. So because we're able to pull down this voting system by pointing this machine to itself, we know that we are able to pull information from the server. And I want to show you why this is so bad and it's such a detrimental vulnerability, because if I were to come in here and we scanned and we searched through all of these files like you would in order to get remote code execution on this box, you can grab files off of this server. And in the case of this specific box on Hack the Box, you're able to grab a password file. So you would have to go through and scan the network, but just to show you, we're not going to do that. We can grab, so this is the local host and it's on port 5000, and we can hit scan file. I was missing this dot here. We can hit scan file and it's going to pull this information from the server, and it's going to tell us that you have the credentials for admin right here. So this would probably be the admin, and then you have the password right here. So this is why server-side request forgery is so bad, is you can pull information that you shouldn't be able to access from the file. So we're going to move on to PortSwigger right here, and they have a basic SSRF against a local server. It's going to tell us to solve this lab. We're going to change the URL access of the admin interface at this location, and we're going to delete this user right here. So let's open up the lab, and the way we're going to go about solving this is, I forgot where it told us this is located. I think it said inside of a check the stock feature. So if you come over here and we open up burp, we can turn, actually we need to be inside here. Now we can turn intercept on, and we can check the stock, and we'll send this to repeater, and then we can just turn this off. Okay, before we change any of this, we're going to send this to repeater so you can see what we get back. This is the normal request. This is what we get back. We get back a response of okay. But if we just delete this whole thing right here and we paste in the local host, and then we go to the admin and we send this, we're going to get back a different page, and we're actually told that we've reached the basic SSRF against the local server. And I think we're supposed to actually delete the user Carlos right here. And so the way we would go about doing this, actually before we delete him, I want to try something just because I just showed it. We can go 127.0.0.1, and this should send us to the local host as well. See if we get back the same thing, and we did. So this is what we would do, is you can type in localhost right here, or 127.0.0.1, and then we're on the admin page. Now what we need to do is delete the user Carlos, and I'm guessing this is supposed to be done from the admin panel. I suppose you could read through here and maybe it might tell us what we can do from the admin panel. Oh, it tells us right here. It says we need to delete the user Carlos. So you could actually just copy this right here. Look, it says we can delete these users. It actually tells us we can delete a bunch of users, and we can paste this in here. We got too many admins going on. We can delete that all the way back. Now, if we hit delete, this right here should pop up to solved. So if we send this, it tells us not found. I think we have to follow the redirect, turn the proxy off, and it tells us that we have deleted the user Carlos. So this is how a server-side request forgery works, and I want to walk you through this one more time. So now I want to bring you back to this flowchart right here, and now you understand that what we're doing when we are the user and we make a request through the URL, through something like this, and let's say we want to get a file, you would do this right here. And if you were on a Linux machine, it would look something like this. And you could try and pull down the Etsy passwd file. Actually, I'm not sure if there's supposed to be a colon there or not. So you can Google and check that. I can't remember. But it would be something like this to pull down the Etsy passwd file. And on Windows, you're going to be trying to pull down some kind of Windows system file that would just be on the server to see if you can get files, but you wouldn't do this necessarily in a proof of concept. What you're going to do is, like I showed over here, with opening up a Netcat listener and then making a request to the URL, which is going to be your own IP address right here, to see if you get a connection back. A quick tip to see if you're trying to figure out what the server is, if it's Linux or Windows and you want to know what kind of file to look for, you can actually just ping the server and see the Hack the Box is a Windows server and it's 239. Whenever you see this TTL of a 127 or a 128 or something in the 120s, it's going to be a Windows server. And when you ping a Linux server, it's going to be somewhere in like the 65 range. And that's one way to tell what kind of server you're going up against. You can just really simply ping it, or you can run an Nmap scan and it will tell you. But this is server-side request forgery in a nutshell. You're the user and you make a request through the URL to the website, and then the website requests the URL from the server, and the server sends the data back to the website, and then you're able to view it as the user. And if you are able to manipulate the URL request to the server, you can grab files from the server that you shouldn't be able to access. Okay, so before we move on from server-side request forgery, I really wanted to show you one more thing that you might come up against in the future. So we're here on Forge from Hack the Box, and you have this upload from URL, and I'm not entirely sure how it's going out and grabbing the URL or an image from the URL, because this is apparently a gallery website and you can post images to the website. So we have upload an image. You can upload through the browse like this, or you can upload from a URL. So I imagine it's doing some kind of wget or something like that. And we know that we are on a Linux box, so you can try and do some stuff here. We'll just ping it real quick. So if we ping the IP address, you can see the TTL is 63. So that tells us we are on a Linux box. And so if you wanted to, you could do something like a file / and then we would go etc passwd, and we can try and pull this down, and it tells us that we're not allowed to do this. So we're on a Linux box. We're not allowed to grab files directly from the server this way. So I'm going to put this in burp and we'll play with it in there. So we can, and we know that the URL is working because if we come out here and we set up our Netcat listener like we have been doing, and we put in our IP address, which I have up here, which is 10.10.14.6, just like this. And we hit that, it's hanging, and we see it reach out to our box right here. We can close out of that. So we know the URL is working. Now we just need to figure out how to get the SSRF to work. So we can come back over here. We'll put this in burp and then we'll play with it. So we'll just put in our own IP address right here. We'll turn intercept on and we'll submit this. We can send this to repeater. We can turn that off, and it's going to give an error because there's nothing for it to connect to, but that is okay. So over here in repeater, we have this right here. And if you remember to un-URL encode, it is Control-Shift-U if you are on a Mac. Not sure what it is if you are on a Windows box. So there's a couple of different ways to get this SSRF to work. And I actually want to try something real quick that I have not tried on this box before. I want to see if we can bypass the filter by going file / etc passwd, and I believe this actually needs 3 right here to work. And so what you see we did here is we saw that it didn't work with just etc password, but it might just have a filter on the box, and if we change some of the casing, it may work for us. And it tells us we have an invalid protocol, so it has to be an HTTP or an HTTP request. So we're not able to just pull down a file because it's requiring HTTP in order to be in the request. We're not going to try and grab the etc passwd file. So what we're going to do now is just try and make a request back to the server and get it to work. So in a bug bounty world, if you come across something like this and you're just trying to prove that you can reach back to the server with a request, what we're going to do is just try and query the server and see if we can get this to tell us something other than an invalid protocol. So if we come in here and we go to the actual URL, which we have right here, which would be forge.htb, and we send this, we get told it is blacklisted. So you're not able to go to the actual URL right here. But if you do like we tried with the file pass, with the Etsy passwd file, you can just come in here and type in forge, and you can just change a few of these characters. And now if you send it, it tells us we have reached back to the server, and we are not getting a blacklisted message any longer. So this is one way to try and bypass like a blacklist or something on a server. And if you come in here and you do a 127.0.0.1 and you send this like we were doing earlier, it is blacklisted. But the actual IP address, so if you wanted to get the IP address of this right here, it tells us that this right here is blacklisted. But if we actually wanted to get the IP address, let's say we're on like Yahoo or something and we want to know the actual IP address of what we have going on right here, Burp will actually tell us what the IP address is really easy. You can just come over to your proxy and turn your proxy on, and for that, and we can come to our URL upload. You can just type something in here, doesn't matter what it is, submit it, and when you hit this, it'll tell us like the request is being sent to forge.htb, but the IP address is 10.10.11.111, and we don't really need that request. So what you can do, since this is blacklisted and this is blacklisted, you can just try the actual IP address to the server, and in this case it looks like this, and you can send it, and you can see that it went through. So the IP address, ironically, is not blacklisted. I'm not sure if Hack the Box meant for that to work or not, but it worked. So you can actually try several different ways to get past the blacklist within a server-side request forgery, and this is a few different ways to do that. Okay, so I think we're going to go ahead and pause on SSRF at this point. If you have any questions on server-side request forgery and you'd like to see something in more detail, please let me know down in the comments. But in the world of bug bounty, this would be plenty to get you by. However, if you're going to be a penetration tester, you're probably going to have to dive into SSRF in a little deeper context. That way you learn how to take a server-side request forgery and turn it into remote code execution. But I think that is out of scope of this video, so we're going to go ahead and pause this here. And if you would like to see more server-side request forgery in the future and how to turn this into remote code execution, please let me know and I'll get to that. All right, before we close out this section here on the server-side request forgery, I thought I would pull up the Hacktivity, and I was reading through some of these recently, and you can just see, look at how high the impact is for server-side request forgery. And I was reading through how some of these were done, and this one right here was really cool, and I thought I would show you how this actually works. And so I went and read through this, and I actually did learn a little bit about the exploit, and it was pretty cool. And I came back to the Portswigger Labs and was playing around, and I found out something I did not know before. So if you come in here where this server-side request forgery is, and you remember it's right here inside this stock API, we can send this over to Repeater, and if we do the unURL encode it, we have this right here, and we can see what's being sent, but we'll go ahead and put that back. But what you can do that I didn't realize we were able to do is you can just add in another parameter. If we were like breaking this right here and it wasn't working, we can just come in here, put the and sign, and type in stock API equals, and then we could just do the local host, and then we can go /admin because we're supposed to pull down the /admin panel, and we can send that, and we need HTTP // and it works for us, and it pulls down the information we needed in order to delete the user Carlos. So I didn't know beforehand that we can just add in new parameters right here. And so I thought this was something that was really cool, that you can add in extra parameters in here in addition to the one that's already there. So you don't actually have to delete this first one. You can just pull down pull down a second one, and then also reading through the Hacktivity, I noticed, I think what we'll do is just delete this first one so that way it looks nicer so you can see it. And so we'll send this and we don't get quite as big of a page back. When you're doing something like searching for an SSRF, I noticed a few of the Hacktivities were they had hit a line like this that's accepting in a parameter, or even up here in the URL. And what they just started doing was they would say and URL equals, and then they'd put in 127.1, and then you could just leave it like that, and they were sending this. And it would be easier to test for this if you had it in repeater. So we can grab this, send it to repeater, not sequencer, send this over, turn that off. And then if you send this, you'll see it doesn't actually pull anything back for us. And you can search for the word delete over here as if we were going to delete the user, and there is nothing. But you could search, you can try this URL, you can try URLs and send that to see if this is a parameter that will actually reach out to the server. Usually it's going to be saved as a URLs or a URL, something like this. And this is not vulnerable. This actual lab is not vulnerable with the URL parameter because the URL parameter is not the one that's making the request out to the server. But you could very easily change this with a change the request method, and then delete this and just add in the stock API just like this, and this should work. I think we have to make it so it says it needs to go to the admin panel. It needed this up here, products, and then in the stock directory, and I forgot HTTP // So basically this is just remaking this request over here, but this should work now, and it does. So you can play around with these when you're in a live program and see if you can find a parameter that actually does hit the URL. So if you come over here and you open up this and you're reading through it, what's really interesting inside of this guy's explanation is there was actually a notification that says this right here is reaching out to the URL parameter, which just pretty much tells you that it's going to be vulnerable to a server-side request forgery. And when he tested it right here, it works. Now this guy had to do a little more to it, and I don't want to read all this to you, so you can come out here and read it, but he had to do a little bit more in order to get this to work through a token, I believe it was. But it was a pretty cool server-side request forgery, and you can come over to the Hacktivity now that you understand how server-side request forgery works, and you can read through some of these and see if you can learn additional ways to pull off server-side request forgery. So with that, I'll see you in the next vulnerability. All right, welcome to the section on command injection. This is probably going to be one of the most severe vulnerabilities that you will ever come across. This vulnerability gives you the opportunity to execute commands on the server and get information back, and possibly even get a shell on the server. So this is one of the most severe vulnerabilities that you will probably come across, because you can just compromise the server and all of the information on it. And if you're in a penetration test, then you can try and move around within the network. So let's go ahead and dive into command injection. Okay, we are going to be talking a little bit about command injection, and there's not really a whole lot of places to practice command injection that I know of. Really, it's just TryHackMe and then PortSwigger, which we'll come to here in a little bit in practice on. So with command injection, what we are able to do is put commands into the server, and then it tell us back. It'll give us the information back for whatever we sent the command in for. So if we send a whoami command, it will tell us who we're running as on the server. And so it says here, a command injection vulnerability is also known as remote code execution, because an attacker can trick the application into executing a series of payloads that they provide without direct access to the machine. So this might sound a little confusing, but it's going to make a lot of sense here in just a second. And so their example here is the whoami command. and I'm going to go ahead and launch this box, and then once it is loaded, I will bring you back. Okay, so this is now loaded up and ready for us to practice some command injection. But before we do, I want to show you kind of what is happening. If we come over to a terminal here, and the first thing I want to do is copy this to make sure we know what kind of commands to send through to the server. But really, you could just put in an who am I, and you could probably figure it out by that. But we can also type in ping and then the IP address that we just copied, and then you can hit enter, and we see that the TTL is 61. So we know that this is going to be a Linux server that we are up against. So now it tells us to use this handy web application to test the availability of a device by entering its IP address, and it's just going to go out and reach to an IP address. So a way to test this is to see if we wanted to check our device. We could come over here and set this up, and my IP address is up here, so we could say 10.2.42.96 and execute and see if we can get it to reach out. And it sent a ping out to our box, and it did not connect, but it pinged our box. So this is just sending a ping. It's not actually trying to connect. So what we can do with this now is you can just type in 127.0.1 and you can execute it, and it's going to tell us, it's going to give us back another ping of the box. And I guess I didn't need to ping it because it tells us right here it's going to be a Linux box. So some of the things we can do, I actually played around with this. That's why you can see these in here. I wanted to see all the different commands that it actually let me send. So I wasn't just sitting here testing everything for the first time. So here's a couple of the command injections that you're going to need to know. If you come in here and we type in 127.0.1, you can do an and sign like this. 0.0.0.1, we can put in an and sign just like this, and then we can do a who am I, and it'll execute. And you can see that it says we are www data, but we still get this ping right here. And it is possible in the coming lessons that we just don't want to see all of this ping right here. So what you can actually do is just put in a bunch of mumbo jumbo, and then you can use a double pipe and do the who and then do the who am I, and it skips the ping and we get the www data. But if we run this command right here and we don't double pipe it, you only do one pipe. Oh, it still works. Okay, I was going to say that it doesn't work, but it worked for us. So we still get the www data. So sometimes it won't work with one pipe, and you'll want to send through two pipes, and then sometimes you'll also have to have like a pipe afterwards and run it, and that time it doesn't work for us. So you will, in the wild, just have to play around with this. So we get the who am I, and it tells us we're www data, and you can type in ID and see how we're sending commands through. So if we come back over here and I type in ID, you can see we get this back. So we're actually communicating with the server, and this would be a very, very bad thing in the real world. So there's one more thing I wanted to show you, and that is this ping right here. If you were doing a blind command injection and you wanted to know if you could reach the server but you weren't getting any information back, you could run the regular whatever's up here. Sometimes it's not going to be something like this. You're not going to be pinging a server. It'll usually be a parameter with an equal sign, and then you put a command in over here. But you can ping, and the -C with the 10 is going to tell it to delay 10 seconds. So we'll actually put in 5 seconds so we don't have to wait quite so long. And it's going to ping itself. So if you watch down here, we have the seconds, and we'll hit it when it hits 10 seconds and wait for it and see if it comes back in 5 seconds. If so, then that works, and it did. So we pinged it, and that's how you do a time delay, which we're going to see in just a little bit. You can also run these with this and sign right here. There will be times that you'll need to try this, and you can actually, if you're getting stuck on command injection, what you can do is go out to Google and just type in command injection bypass and just look for different windows command injection bypass. Maybe you'll have to do some URL encoding or something of that nature, and you can just bypass whatever filters they have. So you can also do with this, you can do two two and signs, just like this, and it should still work for us. And we'll send that over and see if it takes 5 seconds and it comes back. And then I want to try one more thing. I actually have not tried this yet, but because this didn't reach back on our Netcat, I want to try this again. We'll set up a Netcat listener, and we're going to set it up on port 4000 and see if we can actually get this to connect back to us. So if we do this right here, we can do our pipe. We'll actually do a double pipe, and then hopefully we have Netcat available, and we can type in our IP address for it to connect back to. So 10.2.42.96, and then -e, and then we'll go bin bash, and then we can execute this and see if it reaches back. It doesn't look like it's going to because I did not type in the port. So we'll highlight this. We need to put a port in here, and I think I did 4000. Execute. It was port 4000, and it did not reach out, so maybe this doesn't work. We'll try one more time, and then we'll move on. And I want to show you one other thing you can try with this. So Netcat doesn't work, didn't reach out to us. So one thing you can also do in this command injection, like if you were going to capture the flag, one thing I would do is I would come in here and I would type which Python and see if we could get a Python reverse shell. And we can close out of that. And let's do something like this so we can get just what we want back. And we don't have any output. Let's see. So this box might not let us get a reverse shell on it. So I guess we're not gonna be able to figure out what kind of Python's on here, but this would be command injection in a nutshell. And I'm guessing we have Python 3. So we could try to get a reverse shell with Python. So you could come to Google and we would type in Python reverse shell. We can try Pentest Monkey, and we could try this right here. So we can set up our Netcat listener. We'll go port 444. And we can type something in here. We got bin. I want bin bash. What do we have over here? And it's possible that this won't work either. And I would suggest typing something out like this in a text editor. Save some time. 0.96, and make sure this says we need Python 3, execute, and we get a shell back over here. So now if we say who am I, we are on the box, and if we type in ID, it'll tell us who we are. So you can get a reverse shell this way rather than just be sitting over here with command injection. And sorry, I kind of fumbled around there. I actually didn't try that before we did this little video here. So this is command injection in a nutshell. This is a great place to practice. So if you have a subscription to TryHackMe, this is a really good place to come over here and practice your command injection. But if you don't, there's also a free way to practice command injection, and we're going to practice it here in just a second on PortSwigger. So let's go ahead, and I'm going to get things set up, and we will start command injection over here in PortSwigger. If you would like to go ahead and open up PortSwigger and get this set up so you can follow along or try them on your own, then you can do that. Okay, so here we are at PortSwigger, and we are on the OS command injection. We're going to do these first three right here because they're pretty easy, and I believe you had to have Burp Pro for this, and so we're not going to do these ones down here. But the first three of these are actually pretty easy, and you should be able to, I think, solve them. I think you probably could solve all three on your own, but for sure you should be able to solve these first two. So we'll go ahead and open this up. And it tells us this lab contains an OS command injection vulnerability in the product ID checker. The application executes the shell containing the user supplied product store ID. So we've seen stuff like this in the past. So we'll access this lab. And it tells us we are not solved because we haven't done anything. So when we have finished this, this should say solved up here. So we can see what burp is doing. It's doing nothing. It's not hooked up. So down here in the check stock, like we've been doing and following the instructions right here in the product stock checker, we can forward that. We're going to check stock, forward, and right here is what we need. Send that to repeater. We can turn that off. And now we have the product ID and the store ID. And this is going to be where the command injection is at. So if you would like to try and solve this command injection by yourself, I would go ahead and give you this challenge. We have found the location, and I think you can figure it out. It's right here. You should try and see if you can figure out some of the command injection commands that you just saw previously and give it a shot. But if not, here we go. So we have this product ID right here of 1, and what we were doing in some of the last ones was we were able to put this and sign in here, but because of the location of the command injection in this post request, we're not going to be able to use those. We will have to use a pipe. And so you can type in a pipe right here and do something like a who am I, and we can send this and see what happens. And it tells us who we are. So that probably right there solved this for us, and it did. But while we're here, let's play around with this. Let's see what happens if we do 2 pipes and we send this. It does nothing. What happens if we do 2 pipes at the end and send it? Nothing comes back. What happens if we just do 1 and 1? And this is just something that I would encourage you to do as you come across things like this. So we actually have it come back with a pipe at the end and the beginning. What happens if we change this to very clearly a product ID we don't have and it still works? What happens if the product ID is wrong and we have 2 pipes and we send it? Nothing. Now, what about this store ID right here? What if we try 2 pipes and we go, who am I? It gives us a syntax error. What about 2 pipes? And we send it. It gives us the same thing. We can come over here and maybe we can say an ID. It tells us who we are. And so you can really just play around with this and see what happens. What if we put a crazy ID number in here? It still works. And then you can just mess around with this and see what works and what doesn't. If we check a who am I, syntax error, we could go which Python like we did before, and this is black because it needs to be URL encoded, which is a plus sign, and we don't get anything back. And I don't think that you're able to get remote code execution on this. So here we go. This would be your command injection right here. We're going to try and do another one on this lab right here. So if you would like to go ahead and open this up and read the instructions, then I would say go ahead and see if you can figure this out. I'm not going to read it just yet. I want you to go ahead and read this and try and figure it out on your own. And if you get stuck, then we'll go over it. Okay, so this says the lab contains a blind OS injection. So if you're familiar with the bug bounty for beginners course that I already have out, then we know that a blind injection means we're going to have to do some kind of time delay, and it's not going to tell us what's in the response. So we have a 10-second delay in order to solve this challenge, and it tells us that the vulnerability is in the feedback function. So with this, you can go ahead and open up the lab. And we have this submit feedback right here. And we can just type in a bunch of gibberish. And I think this is going to ask for some kind of ending for an email account. And we can come back and intercept this. send it. We'll send this to a repeater, and it is possible that this took you much longer to figure out because we have a bunch of different parameters in here that we are testing against. So we have the name right here. So in a time delay, we saw this in the try hack me example that I showed you. You're going to try and do a ping against the server itself and wait for the time delay. So what we would do in a time delay command injection or a blind command injection with a time delay, you will type in ping, and then we have to URL encode it, and it will look just like we did previously. I'm going to do 5 seconds to start out so we don't have to wait. 27.0.0.1. And then if we send this, we'll see right here, this should be like 4,000 or 5,000 when it actually works. So we can try a pipe at the beginning, pipe at the end. We can try another pipe, and I see that I made a mistake. I didn't have the 1 in there, so we'll try this again and say go. Still not long enough. We can add in another one and see if this works. And it doesn't seem like this is going to be our spot. Otherwise, one of these would work. We can't use the and sign in there, so we'll just move on to the next one. We'll say pipe, ping. And I have this, I fast forwarded typing this in so you didn't have to watch it again. So we got our pipe and our ping command. We can send this. We'll turn this proxy off. It's bothering me that it's flashing. We can see that the time did not work, so we can throw a pipe on the end, send it, not long enough. Let's try 2 pipes, and we can send it, and our time is much longer, and we can see that it was almost 5 seconds. So now to solve this, I believe we can type in a 10 right here and send it, and this should give us the solve because the 5 seconds was pretty close. So it's not solved, and it just came back and it tells us that it has solved. So this is a timed command injection or a blind command injection. This is how you would test it with a ping against the server itself and give it a time delay. So with that, we're going to move into the last one of our command injection labs. This one is going to be a lot harder. I think you can figure it out if you've done my bug bounty course and you've also gone through my free ethical hacking course, because the ethical hacking course is going to cover things that are kind of like this when you get into the actual penetration testing portion of that course. So if you've gone through both of those, I think you can solve this. If not, and you're pretty new, you're probably going to struggle with this one, but we'll go ahead and solve it anyway. So we'll open up the lab in a new window, and then we'll read what it says. So it has a vulnerability that is blind in the feedback function, just like we had before. The output is not returned in the response like before. However, you can use the output redirect to capture the output from the command. And it says that we have a writable folder. And then it tells us to solve the lab, we need to execute a whoami command and retrieve the output. So what we're going to end up having to do is send a whoami command to the server, and then we're going to have to save it in a file inside of this images directory. So it's going to be var www images and then the file with an output. So if you went through the ethical hacking course, I think you can solve this. If not, we'll go ahead and solve it together now. So I just had an idea. If you want to try this on your own, I can actually show you over here. We can make a directory and we'll call it test. We'll cd into test, cd to test. And then what we can do is if I type in whoami, I can send this command and I can put it in a file.txt. And now if I hit enter and then we'll ls, you can see this files here, and I cat out file.txt, it tells us that we are Kali, or if I gedit this file, it'll save the response in there. So we're basically going to be doing this right here, inside of this directory right here. So what we're going to do is give a who am I like we did up here, only it's going to be in this right here. And so your command is going to look like this. And if it has to be URL encoded, you'll need plus signs right here. If not, you might be able just to delete this and do it with no space. And then you're going to need to try and retrieve the file with the command injection. And I want to see if you can figure this out. So go ahead and give it a try now that I have given you a hint with this clue right here. Okay, so let's go ahead and solve this challenge. It said it was in the feedback. So we'll come back to the proxy. We can come to submit feedback. We'll do the same thing we did before and just type in some mumbo jumbo at gmail.com and turn our proxy on. Submit feedback, send this to repeater, turn the proxy off. And so here we are at this same page we were at. I'm actually going to make sure that this is in the exact same, the command injection is in the exact same place, so we don't spend a bunch of time trying to send this somewhere that it's not. So we'll go ping. So I wrote the ping command out so you didn't have to watch it. I sent it, and we'll see it was a 5-second delay. So the command injection is in the same place. So we should be able to come in here and say, who am I? And then we'll give our caret, and then we'll give it the location that we were supposed to give it right here. Paste that in, and then we'll say file.txt and send this and hope that it worked. And now I think the way to check this is going to be, we'll need, I think it'll be file, and then we'll want to read this file.txt. So we'll send this. Okay, since this right here isn't working, we're going to just go ahead and assume this is not going to be in the right directory. So what we can do with this right here is we know we had to send it into the var www, and then I think it was images, and then it was our output.txt, which is where we, and then it was our file.txt, which is where we put our command who am I, right? That's what it says. We do, yes, it's in the images. So what we're going to probably have to do at this point is find the images, because we're not able to pull anything from here. So what we'll do is go to the home page and see if we can pull an image somewhere around here. See, we have the products, we have the product ID. We have the image. Okay, so we right click the image and hit open image in new tab, and we have the image, and now we have a file name. I bet we can do this without burp, and then if we can't, we'll open it up in burp. So we'll type in file.txt, which is where we put the file, and it tells us who we are as the user. So that's one way to solve this challenge. It was a lot more, this one was a lot more difficult of a command injection. In the real world, you wouldn't do anything like this. The only time you're going to do something like this is in a CTF. Or if you were on a live pen test. In the real world, in a bug bounty, what you would do is probably just send a ping with a time delay and then submit that, and you would stop right there. But because this is a CTF, it wanted us to grab this user right here, and this is where we did it. We saved it in images, and we needed the file name and the file.txt. So that is the last of the command injection that we're going to be covering, and we'll move on to the next vulnerability. All right, in this portion of the course, we're going to be covering file upload. This can be a severe vulnerability, especially if the file is placed somewhere that you can execute what you have uploaded and get back a shell on the server. So file upload is one that you're going to see a lot in CTFs. They do happen in bug bounty programs. You can go and read on the Hacktivity about some file uploads, but in the world of bug bounty hunting, most of the time they're probably not going to lead back to a shell, but in the world of penetration testing and CTFs, or if you're going for any kind of certification to become a penetration tester, then file uploads are always a good place to look, and make sure when you're uploading a file to see if you can bypass any of the filters that may be keeping you from uploading a specific file with a payload inside of it. So with that, let's go ahead and jump into it. To the file upload. So we're going to be going through a few Hack the Box file uploads, and the reason we're going to be doing Hack the Box is there really is no great place to practice file upload, and Hack the Box really has the best systems to practice file upload. If you have a Hack the Box subscription, then you can open these up, you can play around with them yourself and actually test these out. If not, in the world of bug bounty, if you go to the Hacktivity, you can read about file uploads happening all over the place. So file uploads do happen. We're going to start really basic, and then we're going to have to go through bypassing different filters within the file upload. So this one is really one of the easiest, and if you want to, this box is called October with Hack the Box, and its IP address is right here. And I'm not going to show you how I got to this spot, because really we just want to see the file upload in action and what happens and why this would be a really huge vulnerability in the penetration testing world. So the first thing we're going to do is we can click this file upload, and I tested it. You can upload a file right here. And so what we're going to do is we can just click the file upload button, and I'm going to show you two different ways to go about uploading files and testing this out. So the first is with a web shell. And what we can do is we can come over here like we did before. And what we can do is we can go to Google and just look for web shells, and I can just show you right here. I just typed in web shell, and I scrolled down until I came to the Shushan 747, clicked on it, and we're brought to some PHP web shells. This one right here is one of my favorites. It's the one I use the most. And we can just say that we want to create a gedit, and we'll call it web.cmd. And sometimes you might have to name this like PHP if that's what this server is running in order to get a web shell to run. But we're going to run with CMD, and we'll test this out. We may have to change that to PHP. I'm not really sure. And so we can come back over here. We can upload our web shell just like this. And if we go to the URL, this is a good sign that it didn't give us an error. Now we had to pass in a parameter because we have this right here. It's going to call our web shell when we pass in the parameter CMD. So we can come over here, go question mark, CMD equals, and now we should be able to type in a command here. And if our web shell works, we will receive an output on the page. So we can type in who am I and run it. And this doesn't seem to work. So we will rename this. We'll just go move. So we will type in our web shell, and we will just move it from WebCMD to WebPHP5. And the reason I went with PHP5 is because right here, I should have saw this the first time. It says PHP5. So we can save this, and now we can upload, and we'll re-upload our web shell just like this. And now we can click on it, click here, move that out of the way, and we can put our parameter in here. So we want a CMD who am I, and now it tells us we are www data, and you can use this right here to try and get a reverse shell back over here. But I think what we will do is we will just use the Pentest Monkey PHP reverse shell. So we'll just say PHP reverse shell, and it should be the first one. And so what you can do is go to raw, Command A, Command C. We will come over here, and we will just say gedit, and then we'll call it shell.php5. We can paste this in, and then we'll need to change our port because we're listening on port 444. And over here, we are listening on 10. My IP address is 10.10.14.6. We can save this, come back over here. We could probably close that out. We'll upload this file. We want our shell open, and then we click this right here, it hangs, which means we probably have got our callback over here, and we now have a shell on our box. So I want to explain what is happening now that you've seen this. The way a file upload works. If you upload a file, you have to make sure that you know where the actual file is being stored, because when we upload our malicious code, if you can't execute it on the server, it does you no good. So let's say you can upload some kind of shell like this web shell right here or right here, but you can't find the location on the server of this web shell to execute it, it does you no good. So you have to be able to locate it. And for us, this is a really simple file upload. You just click here and it takes you to the location right here of where our file is that we uploaded. So this is a really simple file upload, and we have this right here. It tells us it's running PHP. Sometimes it'll just say like we'll have a backend. It'll say something like backend.php like this, and then you'll know it's running PHP. Or if it's Windows, you may try ASPX or ASP. And so you're just going to have to get familiar with the systems you're going up against and what you see on the server that you're attacking. But this is a really basic introduction into a file upload. We're going to do a couple more that are going to be a little more challenging, which is also going to be a lot more realistic. In the real world, the chances you just come across something that just says file upload in a bug bounty is almost zero. Maybe on a penetration test it might happen, but in the world of bug bounty, probably not going to happen. You're going to have to bypass some sort of filters, and we're going to do some pretty simple filter bypassing in the next file upload. All right, we are here on the Box Popcorn. Same thing, I'm not going to show you how to get here because we're just covering file upload. And in this one, we're going to talk a little more about bypassing different filters. So if we come in here, we have this edit right here, and it tells us we can update the screenshot, which is going to be this image right here. And it tells us it allows a JPEG or a PNG. And I've never tried JPEG, so we might try that just on the fly and see what happens. But we can save this right here. We can go save image as, and we're in our test file right here, or test directory. So we'll save that. And if we come over here to update the screenshot, we will need to browse, click on our little PNG right here, update it, and submit, and it tells us that it worked. The type was a PNG. And now we should be able to come over to the uploads. We can type in 10, 10, 10, 6, and we'll go /torrent, and then we want the upload just like this. And it tells us here is the image that we just uploaded. So that works. So what we will want to do now is see if we can upload some kind of shell. So we'll just use one of our PHP shells that we already have in this directory. And we'll browse, and we can just try this shell.php5. And if we open this and we submit it, it tells us we have an invalid file. Let's come over here and we will move our shell.php5, and we'll just call it shell.php. And we can try this. And it says invalid file. Now what we can try and do is intercept the request and see what the difference is between these. So if we come to update this, and we want to update this image again, and we upload it, and now we turn our intercept on and we submit this, we can look at the difference, and we'll send this to Repeater just to save it. And we know that this is going to go through, tells us that it worked. Now we'll come back and upload our PHP shell and see what the difference is. So we can come over, we'll try our web shell this time, and turn on our interceptor, send it, we'll send that to Repeater. And we can turn this off now, and we can come over to Repeater and look at these and see what the difference is. So when you come over here and you look at this, right here is what we're looking at. So we have a content type of image, PNG, the file name, which was the link that we downloaded, and then it tells us it's a PNG file, and we have all this mumbo jumbo right here. And so what we can do is just copy some of this, and we can copy, and now we can come over here and we have a file type of web.php, and then we have our little web shell that we used before, and we could just paste this in up above. And so our content type has now changed, and we have these bytes to try and confuse it. And then we have this image, or we have our web shell right here. So I want to show you a little bit of how a server would read this file type. If we come in here and we just say gedit, and we want to make a we'll make a file.gif, and we'll see what happens. And we'll just put in some letters. We save this, we close it, and we go file, and then we say file.gif. It tells us that it is actually text. So if we then come into our file.gif, there is something called magic bytes that we can add in here to try and trick it. The way a GIF starts is with a GIF 89 or 87A, and if we save something like this and run file on it, now it tells us we have a GIF, an image type, and the version. So this is how a server would read this. If you upload something, it's going to run something like a file on it to see if it really is a GIF or if it just has text in it. And so when we copy all of this right here with the PNG, basically what we're trying to do is trick it by putting something in like this GIF 87A, so that way when it reads it, it will read it as a PNG. And we'll actually try this GIF because I've never actually tried it on this box, so I don't know if it will work or not. And we'll just try the file upload on the fly. So if we send this over, it tells us that it looks like it uploaded. So we can see what it looks like. It did upload. So I'm kind of surprised that worked. We'll go check it out. So if we come over to our uploads, we refresh the page, and we open this up, it looks like it worked. We should be able to pass in our parameter of cmd equals, and we can say who am I, and it tells us right here www data. So that actually worked. I was expecting it to not work, and sometimes when you hit a file like this and it does not work, it might check for just a .png inside the file and then the .php. And if you just go out to Google and you read about different ways to bypass filters for file upload, you're going to have a lot of information, and that's really what I would recommend you to do. This is just the tip of the iceberg on how file upload works. So I'm just showing you some basic ways to bypass it, but I would also recommend going out to Google and reading about how to bypass a PNG file upload filter or a JPEG and see all the different ways you can bypass this. So if we come in here and we send this and it renders, it tells us this worked as well. So we can actually go back, and if we refresh this right here, and it tells us that this worked. So there's one other thing. Let's play around with the JPEG. So if we come in here and we close out of this, let's actually just play with it in Repeater and see what happens. So if we say it's an image and we say, actually let's try the GIF because we already have that set up, and we just leave this like this, and we delete all of this, and we just type in the 87A with GIF at the front. Let's see if this works. It says invalid file. So let's take our PHP shell. We'll copy this, and let's see if we can just say, let's gedit this file, and we'll call it file PHP, and we'll add in the GIF 87A. And then we'll put our PHP in here, and we'll save this. And then we're also going to need our GIF file, so we have that in there too. So that way we can make sure that our content type right here is right. So we'll go to proxy, so that way it is ready. We can try this upload, browse. Let's upload the file with the GIF. We'll open, make sure that we catch this. Send it to Repeater. It looks like that is how it goes. I actually want to turn this off it says that it worked. Okay, so it does accept the GIF as well. Now let's upload our reverse shell that we saved in file.php. And we'll send this on over to Repeater, see how we have this application type is different. So we can turn this off and see if we can get this to work as well. So we'll send this and it says invalid file. And when we send this, it says that it worked. So what we can try and do is just grab this like we did before. We'll copy it and paste this in. Should be able to delete this. Does that actually have a semicolon in it? It does, so should work like that. If we send it, it says that it worked. So let's go see if we can find that. Here's the GIF. It says it didn't work. That's not surprising because it's not actually an image. We need our other PHP shell. Here's our GIF with our PHP in it. So let's try and pass in the same parameter equals who am I, and if we send this, it tells us this GIF works and it cannot execute the command within the file. Let's try and just delete this and see if we can get a who am I this way. We'll send that, come back, refresh, check out this PHP, and it tells us we're www data. So it does let us inject a command with a GIF, but for some reason I wasn't able to get the web shell to work. But there's another way to go about this. So this would be a really roundabout way to do this. You could come in and we could try and upload like a Python shell in here, or because we know we have PHP, we could put inside of here, we could put inside of our command right here, instead of doing a system who am I, we could come to this web shell and we could execute a PHP reverse shell like this. But you saw us use this recently. Let's just try and upload this PHP shell and see if we can get this to execute a reverse shell for us. So we'll come back over here. We can edit this again. We'll put in our PHP reverse shell. We can open. We'll need to catch this inside Repeater. Turn our interceptor on, submit, and send over to Repeater. We can turn this off, come to Repeater, it tells us we have an invalid file, which we expect. We have the shell.php, and we'll just use the one with the PNG because we know that it's going to work for us. So we can come over here and we can just highlight this, paste in the PNG. Now if we send this, it tells us that this worked. We can set up a netcat listener over here, netcat, and I think we originally made that on port 4444, and now that's listening. So now when we open up that file, it should execute on the server and it will give us a shell back. We can see our PHP file, we can see the size has changed. So we open this up and it's hanging and we have a shell return back to us, and it's going to tell us I am www data. So that is file upload. So there's a bunch of different ways you can play with this. If you have Hack the Box, I would recommend coming into Popcorn because you have a lot of different ways to play with this. You have the JPEG and the GIF, the PNG, and so you can just come in here and play around with these and see all the different ways you can get a reverse shell from a file upload. And I would recommend, because we were not able to get the GIF web shell to work, you could play around with that and see if you could get a web shell rather than just executing commands one at a time, and then maybe see if you can get a reverse shell from the web shell. because there will be times that you have to do that inside of CTFs. But in the world of bug bounty, you really wouldn't be trying to get a reverse shell. You could just simply do a wub shell and a who am I for a proof of concept. And file uploads are something you're going to see, so you can read about those in Hack the Box. And I would definitely recommend going out to Google and continuing your research on file uploads. But like I said, there's really not a lot of places to practice file upload, and it's because if there's a file upload that is going to be vulnerable on a server, you can get remote code execution. And for this reason, Hack the Box is really the only place that is really good for file upload. TryHackMe has a little bit of file upload, but I don't think it's as good as Hack the Box when it comes to practicing this specific vulnerability. TryHackMe is really great in other areas, but Hack the Box is really good for file upload. So with that, I will see you in the next vulnerability. Okay, welcome to the local file inclusion and the remote file inclusion, also known as LFI and RFI portion of this course. The LFI is going to be one that is more common than the RFI, and the LFI is going to give us the opportunity or the ability to read local files on the server, which could lead to a compromise of sensitive information or data that we're not supposed to be able to access, and files on the server that we should not be able to access. The RFI is going to give us the ability to host up our own files and then have the server reach out to our server that we make on our Kali machine and then execute that file, and will lead to remote code execution on the server. So we're going to jump into the LFI and the RFI now. Let's get started. Welcome to the LFI RFI, so the local file inclusion or the remote file inclusion portion of this course. We're going to be using TryHackMe for our example, and TryHackMe is just too good to pass up when it comes to practicing LFI and RFI. If you can afford a TryHackMe membership, then it is worth it just to come in here and practice your LFI and RFI along with other things. And when it comes to Hack the Box doesn't have any really good place to practice and RFI. So sadly, if you have only a Hack the Box membership, you're not going to be able to practice this. So what we have going on right here, this is a really great explanation. I'm really happy with how they have this all structured. So you have your basic web application right here. You have the HTTP, the URL, and then you have a get.php. And this PHP right here is going to be a giveaway of the way we're going to go about trying to pull this file down. So oftentimes you're not going to see a .php, but sometimes you will. And when you see a .php and then a file equals, just like this, you can think you can try for an LFI. And we've already talked about directory traversal. And typically if something is vulnerable to a directory traversal, you are going to be able to pull down files as well. And once you have LFI, which is pretty bad, if you can turn that into remote file inclusion, then you have got something really, really big going on for you. So we have this URL is going to make a GET request to the server for a specific file, and it's going to equal the file that you click on. And I'm going to show this to you, and I think it will make a lot more sense. So I've already opened up the lab here. When we click on lab 1, it tells us it's got this lab1.php, and you can come in here and you can just type something in. So if we just type in anything, because we don't really want to look for a file just yet. Actually, I'll just show you this way. So if we come in here and we type in etc pass wd and we say include, it pulls it down for us. But this is not going to happen. That's not real world. So what will happen is something like this. You'll come to a page, it'll have like this request right here. You're searching for something and say it's a search bar, and we just type something in and we intercept this in our proxy and we hit include. We'll send this to our repeater. We can turn this off. And now what happens is it tells us, we'll just pretend all this isn't here because this is not going to happen in the real world, but this will happen right here. This file equals and then what we typed in. Now this looks like what we had going on over here, and this really does happen. And up here we can change this, and we can now put in this etc pass wd, and it will pull it down like this. And a lot of times you'll have this file equals up here and you can play around with it, but rather than using the URL, I would rather use burp. So we can come over here and we can say send And I like that it tells us we have this Nginx server right here. And I'm sure if we ran like an Nmap scan, it would tell us what we're up against completely, but we're not going to do that. We'll do that in just a minute with an LFI on a Hack the Box system, and we will test it there. But we have this file equals, and then we have right here where we can ask whatever file, we can ask for whatever file we want. So right here, we can put in our etc pass wd, and we can send this. And on the page, it tells us we have users here. And when you're looking for users, you can look for the bin bash. That's going to tell us people who have actual users on this box. There's actually quite a few of them, or a bin sh, not a bin bash. We have root has a bin bash. So when you pull this down, you can look for users. And it's even worse if you can access the etc shadow file, because then we can actually pull down password hashes, and we don't have the ability to do that. So this would be a file inclusion, and you can pull down all kinds of files from the server. So you can actually pull down, let's say we wanted to look at the index.php. You can send this, and it'll pull down, I can't tell if that worked or not, because there's just a bunch of HTML. Let's render it, maybe we can see it. Yeah, so it just pulled down the home page like right here. So you can look at different pages in here. So let's say you were able to you were to do some kind of fuzzing on this page, and you were looking for different directories, and you had a directory that you weren't allowed to look at, like a hidden directory. In here, you could probably include this in the file, and it will pull down that hidden page below right here. And because we're able to do this local file inclusion, when you have local file inclusion, it's a great vulnerability to find. It's one that it's a pretty severe vulnerability, but if you can turn this into a remote file inclusion, then it becomes something more. So right now we have what's called local file inclusion. We're able to get local files that are hosted on the target server. But if you're able to have remote file inclusion, that means we can include files from our box over here. So if you look at what we have in this file, we have a shell.php right here and a web shell over here. If I have remote file inclusion, I can have this GET request reach out to my server over here that I can host up, and I can host up this file right here, and it will go get that file and then execute it, and then I can have remote code execution on this server, and I will own this network. So what this looks like, an easy way to test for this, like if you were to do this in a bug bounty program and you were just looking for a proof of concept, you would just type in sudo python2 with a simple server, and then we would just put in our IP address and see if it reaches out to us. So we can go http 10.2.42.96, and we can send this and see if we get a hit over here, and we do. So this means we can actually get remote code execution on this server. So what we can do now is close out of this. We'll rehost up those files, and I've already edited the shell.php, so you wouldn't have to watch me change the IP address right here. So it's all set up and ready. So we can host this back up. We can come over here and say netcat port 444, and if we send this right here, we want it to grab shell.php, and now if we send this, it's going to hang right here because we have a shell, and we could say who am I, and it now tells us we are www data. So we now have code execution on this server, and this would be pretty much as bad as it gets. Now I want to show you a little more local file inclusion and how to read pages when they don't render over here when we ask for a specific file and we want to see what's happening. And I'm going to switch over to Hack the Box for this. All right, I have loaded up the box Poison here for us, and if you have a Hack the Box subscription, it would definitely be worth your time to open this up and play around with it so you can see if you're able to find any of these LFI files on your own. So we're going to go ahead and just play around with this for a little bit, and I want to show you some of the things you can do with LFIs that can really save you a lot of time, and if you're doing CTFs, help you find files that you shouldn't be able to access. So we're going to do the same thing we did before. We'll just put in some characters in here, and we're going to catch this over in our repeater. So we'll hit submit. We'll send this over to repeater, and then we can turn our interceptor off. And now you can see before we didn't have this file right here with the browse.php and then the file and then our request. So you can, like I showed earlier, try and get files right here like this, which is fine, but I like to use repeater just because it goes a lot faster. So we're going to go ahead and use repeater. So we'll hop over here, and if we send this, we get this simple message over here saying that it failed to find this through the inclusion, and it tells us the path we're using right here. So what we can do at this point is we can try and type in etc pass WD, and if we send this, we can see we have the etc pass WD file. You can see we have the etc pass WD file right here. And something to always look through is this server version. You can highlight this, copy it, go to Google, see if there's any vulnerabilities, and check that type of stuff out, especially when you're hunting for bug bounties as well as penetration tests. It's always worth looking at. And then we can see the users on here is going to be this one right here, and then we have root right here is a user. The rest of these don't look like they have the ability to log in. Now on to looking for more files. There's a really simple way to go through the files really quickly, and I've used the tool Fuff a lot on my channel. So we're going to go ahead and we're going to use Fuff, and I'm just going to leave this in here and delete this a little bit at a time. Actually, we'll just delete this whole thing. So we can delete this. What we'll need to do is highlight this and copy it, paste it into Fuff, and then right here we're going to want to fuzz, but to make sure we make it all the way back to the root, I'm going to just put some of these dot slashes in here so that we can make sure we go all the way back to the root. And then we're going to fuzz, and we don't want to fuzz this with the web content. What we want to look for is the LFI content. So we can come back over here, and I think we just type in web. Nope, we don't want web shells. We want fuzzing right here, so we can type in fuzzing, and then we want LFI, which is right here. So we're going to go into that directory and see what's in here, and we'll use this one because we're up against a Linux box. So we can just type in Linux. That did not work for me. We'll type in like that, and now if we run this, it should work for us, and it does, but we don't want all of that output. So we're going to filter by lines, and we're going to say if it has 5 lines, don't include it, and it's going to give us all the files that we're able to look at. Now, if I was actually doing a CTF, I would look through every single one of these to see what we can find. Now, obviously, we tried the etc pass WD, but you can come through and check out all of these files and see if there's anything helpful for you to try and get remote code execution on the box. And because we don't have an RFI, which I have not actually tried, so we'll go ahead and try it and make sure that this does not work. And we can put my IP address in here, which is 10.10.14.6, and it doesn't hang, no RFI. So we aren't able to include any of our own files to get a shell back that way, but you could look through all of these and see if maybe you can find some credentials or something, or maybe be able to SSH into the box. But this is a quick, easy way to fuzz when you have an LFI. And in a real bug bounty situation, you wouldn't want to actually enumerate any of this. You would only do something like that on a CTF. You would really just test for an LFI like I've already shown you and make sure that it is there, and then you would submit a report. Or if you were testing for an RFI, you would just do what we did right here and set up a simple server and see if you can reach out to yourself for an RFI. And that is the remote file inclusion and the local file inclusion. You can go ahead and play with these if you have a TryHackMe and a Hack the Box subscription, and get used to seeing these. You're going to see them a lot inside of CTFs, especially LFIs. RFIs are a lot more rare, but they do happen. So with that, we will move on to the next vulnerability. All right, we are going to be going over some insecure deserialization, and I decided to make a little flowchart here so that you could kind of see what is going to be happening. And this is for PHP, but the concept is going to be the same for Python and JavaScript as well. But the examples we're going to be dealing with is PHP, so I decided just to show you PHP. It'll make it a lot easier for you as we continue going. We're going to have just a few places to practice. This is something that there is not actually a lot of places to practice. So I wanted to show you here, and then I think I'm going to show you an example, and then you should be able to solve a few challenges on your own. And if not, we will walk through them together, and I think you'll get the hang of this pretty quick. It's not super difficult, but it is something that a lot of people are afraid of. But nonetheless, let's jump into it. So we have what's going to be the waiter, and he is the object. This would be like if you have inside of programming, there's something called object-oriented programming. And I don't want to get too much into it, but just know that like this is the object, and the object can contain different things within inside of it. So you have the waiter, and he carries a plate. And so with the waiter, the question would be, does the waiter have a plate? And it's true or false. This would be a Boolean, and within PHP, it's represented as just a B. And then it'll say B equals, and it'll be 1 or a 0. So that'll be either true or false. So does the waiter have a plate? And it would say true. And so in this case, it would say waiter have a plate, B equals 1. And so you'd say here the waiter has a plate. And then if he has the plate, we come down here and it says like, what is on the plate? Well, on the plate, there may be a username, and the username, when you see these quotation marks like this, is stored as a string. And so the username has a string. And so within a object, you would see something like S username, and then it would have the name, and the S is going to stand for the string. And then you will have like maybe the person that is being, and maybe the object is going to contain an age. And so on the plate, there's going to be more data, and it is going to be an age, and it's going to be 25, and it is an integer because it's a number. And so this would be represented as an I. So it'd be like I age equals 25. And it sounds confusing, but we're going to see what this looks like here in just a minute, and it will all make sense. And I'll come back to this and show it to you once we get a look at the full picture of what this looks like inside of a cookie. So let's take just a step forward, just a little tiny step forward, and look at how you're going to go about exploiting this, and then we'll go ahead and exploit some of these insecure deserialized objects. All right, so I have opened up a TryHackMe box here, and sadly it's not a real great example for an insecure deserialization vulnerability because I already created a username with the name. My password is name, and if we log in, it brings us to this page. But in the real world, if you came to something like this and you just fuzzed this with a fuzzer, like something like Fuff or GoBuster or Derb, and you would find this directory called admin, and bam, you're here and you're in the administrator dashboard, which is kind of a bummer because you're just automatically in here, and it tells you like, here's the flag, and you've made it inside of the dashboard. And so what we can do from in here, I want to test this in here, and then we'll go back to our user profile, and we can just inspect this like we normally would. We'll come over to the memory, which is where the cookie is going to be stored. We'll come over to the storage, sorry, not the memory, where the cookie is going to be stored, and it's going to say we have a password, our session ID, and our username and our user type. And in changing these cookies right here, you can manipulate the user type and the username. Now inside of Burp, this also wouldn't be in plain text like it is right here, but if we intercept this and we refresh this and we say forward, we'll come and we have our interceptor on, and we'll come to the my profile page again, and we forward this to right here, and we send this to repeater. You can get a look at this. Like, here's a username, admin, password right here. Like, this is what we changed, and we have this base64 cookie right here. Let's see if we can decode it. We can get some of it, but what you would do with this is usually not going to be in plain text. It would be base64, and you would have to decode it, and then you can change these things right here. So with that, I want to send you over to Portswigger, and we're going to go to the insecure deserialization right here, and we're going to walk through some of these, and you're going to get the hang of them pretty quick. They're not as challenging as you might think. So we're going to do this first one right here, and if you want, you can go ahead and give it a try and see if you can figure out how to pull this off. But I want to walk through this one right here, and then we're going to go back to the flowchart because I think it's going to make a lot more sense once we do. So you can go ahead and give this a try if you would like. Load it up here, and the instructions tell us that we need to use a serialized base session mechanism and vulnerability, and we're going to try and exploit it. And it says here's our credentials to log in, and we need to delete Carlos's account in order to solve this challenge. So what we'll do is we can just come over here, and we'll need to make an account, and I'm going to call my account name and my password name. I'm going to intercept this just in case we end up needing it. So we'll intercept this, we'll send it. I'm going to send this to repeater. I don't believe we're going to need it though. So we'll leave that there. Come back over to our proxy. Oh, we need to log in with the username that it gave us. So we have right here our username and Peter. So we'll log in with this, and then it tells us we need to go to the admin panel. We need to use the session cookie to go to the administrator panel or privileges and delete Carlos. Okay, so what we can do here at this point is you're going to come to this my account, but we're going to need to intercept the request. It will look like this. You can send this to repeater, forward. We'll send this to, I don't think we need that one, but we'll turn that off. We'll come back one, send this, and see what it looks like. And what we can do is, you might have this little interceptor thing closed, open that up. We can highlight this and it'll decode this for us. And it's going to tell us, are we an admin? And if you remember, this is the object right here. So the object is called for, and it is a user. And then we have a string, which we have our username, and we have another string, which is our, well, right here is our username. And then it tells us we're an admin, which is also stored as a string. And then we have this right here, this Boolean, are we an admin? And it is set to false. But we can go ahead and change this to true. We can apply the changes. I'm going to highlight this cookie just in case this doesn't work. We can send it, and it says, okay, it worked. If we refresh the page, it didn't update our cookie for us. So we're going to have to manually come over here and update our cookie. And right here's the cookie. Paste in the one we just made ourselves. And now if we refresh the page, we should have access to an admin panel, and we do right here. And you can delete Carlos if you would like this to say solved right here. The next one is going to be pretty similar and not really much more difficult than this. If you struggled, I struggled the first time with figuring out that I needed to actually copy the cookie and inspect and paste it in. That's okay. You're going to need to do that in the next one as well. But we can go ahead and hop over there and check that one out. All right, so we're going to go ahead and do this second one right here. And what you will need to do is, I just opened it up in a new tab, and I also opened up the lab so that way we don't have to wait for that to load. So we'll read the instructions, and it tells us we're going to need to gain access to the administrator account and delete Carlos once again. And we have the same username and password. So if we come over here we're going to do the same thing we did before, and we will log in just like before. And now that this has logged us in, we'll come to our proxy. We're going to intercept the request, check out the My Account page, send this to repeater, come over here, send it, see what happens. We get a 200 OK. And now we're going to mess with this cookie once again. And you can see it looks like there is a lot more going on in here than last time. But you can break it down just like before. We have our object, and then we have a string with our username right here. We have the username, and then it tells us we have this string right here with our access token in it. And then we have this going on right here. So what we would need to do with this at this point is this access token is obviously going to be bad for us, because it is going to be telling us what we can access and what we can't access. So if we just delete that, and then we just put in here the B1 to make this true, we can apply the changes. We can actually send this to make sure we don't get an error. And it says 200 OK, which means this token should work for us right here. And so I'm going to copy it out of the box just to make sure I don't get anything wrong. And now what we'll need to do is come back to our page. If we refresh this, nothing happens. Even though we sent it from burp, we'll have to inspect and check out the cookie over here, change our cookie, and then refresh the page. And we have the admin panel. So this looks really easy, but this one actually took me I would say almost 15 minutes to figure out what exactly was going on inside of repeater. I'm not real great with PHP. And so when I was trying to figure this out, I finally got this to go. I accidentally left this in a string the first time, which is something you may have done. And if you try and leave this inside of a string, it is going to give you this error over and over and over again. That's one mistake that I made over and over as I was messing with this. And then the other mistake I made was I deleted this and applied changes. And if you send it, you'll get the same error. And I forgot to delete this. So this is really finicky. And in the real world, you're going to have to do pretty much what I did and just keep testing this over and over and over until you get a 200. And then you'll know that something has worked for you. And one of the other things that I didn't understand, and I don't understand still, so if you know PHP, you might understand this better than I do. I have no idea why this says we have an integer of 0 in order to get this exploit to work. This is not how I solved it, and I honestly don't have any idea why this access token is an I with a 0, but it does work, and the way I did it ended up working. So if you come over here and you change this to a 0 with the Boolean, you are going to get this error. And then if you come in here and you solve it the way the solution says with the integer of 0, apply the changes, you can send it. It works this way as well, and this cookie works. But just being honest, I don't know why this works. My version makes sense to me because I have the access token, and I'm just going to say that it's true, that I have access to wherever I want to go, and I send it and it works. So if you know why this works with an integer, you can feel free to leave a comment down below, because I'm really interested. I don't actually know. I actually Googled to try and figure out why this works with an integer, and I couldn't find anything. So with that, we will move on into the next vulnerability and keep going. Okay, so now that we have looked at the insecure deserialization examples, we're going to come back to the flowchart. So now if you remember the object right here, so we have our object, which is the waiter, and it is carrying the plate. And on the plate, we have a username, which is Peter, and we have the access token right here. And so we have a object, we have a string and another string right here, and it says that this is also carrying a string. And then we have our Boolean, which is going to be true, which allows us to log in as the administrator. So now when you see something like this, you should be able to understand what's going on, at least without it being really, really complicated. So here's the flowchart. Once again, this is how the insecure deserialization works. I hope going from the beginning of this flowchart to now, it all makes sense and you can understand what is going on. I'll see you in the next vulnerability. Okay, so as we move into this next section, we're going to be dealing with cookies and auth tokens. So I decided to go ahead and do the first half of the box, Luke, on Hack the Box. It's going to be dealing with a JSON web token, and I decided to show you this because I wanted you to see walking through the process of finding a token and changing it and just how to understand what is going on. And then after we look at this box, I'm going to set you loose on 2 labs and you'll be able to practice manipulating these tokens on your own, and then we'll do walkthroughs with those as well. I thought it'd actually be helpful to go through the first half of the box, Luke, so that you could see a little bit of the enumeration. And I've had a few people asking to do more with APIs, and this box will actually show you how you can communicate with an API. I'm going to show you with the actual command line, as well as enumerating an API with burp as well. And so we'll go ahead and jump into this. All right, I have already set up the box and I have it running. So we should be able to ping. The IP address is 137 and we can see it's a Linux box right here. And it is all up and running and it is ready for some enumeration. We can run an nmap scan like this. And so we can go ahead and run this nmap scan and we can see port 80 comes back really quick. So we can run a GoBuster, or we can try and use FUF on this box. And we will use a directory list. I imagine a small one would be just fine, but we'll use the medium one just to make sure we're able to find everything that we need. And I forgot to change the IP address here, so we'll fuzz this while our nmap scan runs. So we got 137, and we'll go ahead and send this on our way. We can actually come out to the IP address by typing in 10.10.10.137 since we know port 80 is open, and we are brought to a web page like this. We can click around, see what's going on. You guys know I like to view the page source. I like to look at a lot of the hrefs and see what's in here. I wonder if it has a login in here. Nope. And we can come back and see if FUF has found anything. We got member, which was a redirect. We can check that out. See where it redirects to. And it doesn't tell us anything. And we can check our nmap scan is still going. We have port 21. If this was a penetration testing course, I would go out and check port 21 and FTP. But because it is not, I'm going to let these scans run and I'll bring you back once they have finished. It seemed to be taking longer than I anticipated. So what we're going to do is we're going to check out a GoBuster, because I like to use GoBuster when I need to run an extension such as PHP, and FUF does not allow me to do this. So what we're going to do is come back over here and we're going to run our GoBuster with as well as FUF with the extension PHP, because this wasn't working for us, and we have a bunch of stuff coming back. So we can check out the login page. This usually is not going to work in a bug bounty program, but you can type in something like admin, and it doesn't work. And so you can try default credentials and see if it works. Usually there will be like a made by down here, but there doesn't seem to be, so we can't check for any default credentials on this page. We have a config.php, which is always a good thing to look at, especially when you have code execution on a box, because it will pull down often the username to the database, which is root, and we have a password as well. And one thing you should know by now, especially if you're in an intermediate course, is that people reuse their passwords. So we can copy this password and we'll check our nmap scan, and it has not told us, but it will tell us when it is done that there is a port 3000 But before that, you could come back to this login page right here and try and log in with root and that password we just copied to see if it would work, and it doesn't. And we could try admin with that password to see if it works, and it doesn't. You could also try administrator or other things like that. But we're going to go ahead and open a new tab. And at this point, we are going, and before we mess with this new tab, let's go and check port 3000. And we find that this has that we are getting back JSON, and this is an API. So we are going to see what we can figure out. It says an auth token is not supplied, and we can curl this and see what happens and see if we can log in, because that is how we're going to have this auth token. So we can come over here and type in curl, and we're going to use a post, and then we will go HTTP and the IP address 10.10.10.137, and we're on port 3000, and we want to log in, and I can show you this right here. If we go /login, and the way you would find this login page is by fuzzing the API, which I showed in the beginner bug bounty course. So we know that we need to authenticate because that's what it tells us. And we need this login page right here, and we need to pass in some parameters, which is going to be our username. So we'll go username, and we were told the username root. We can try this because that's what we saw on the config.php, and we'll need a password as well, and we can try the password that we found, and then we can close all this off and send it, and it tells us forbidden. It does not work. We're not able to curl it, so you could come over here and try admin like we tried before, and I spelled admin wrong. And we get a token in return, which is what we needed. So now what I would do is come back here like this. We're going to go to burp, and we're going to intercept this request. We'll send this to repeater, and we can let that go. If we send this, it tells us, let's try login and send this. Okay, and we get an okay back, and it tells us we need to authenticate. Now, what we need to do is create a token. And so we'll need an authorization token, so we can go authorization, and then we'll use a bearer, and then we're going to paste in our token right here, and you can nice and easily highlight to see what's going on here. So because this is a JSON token, we have this right here, and this is going to decode this for us over here in our inspector. And if yours is closed, you can open it up, and we can see that this is just telling it it's a token. Looks like it's SHA-256, and this is the algorithm for it. So you'll see this again later. And so this is about the token, and then this second part is going to hold the information inside the token. We have the username, admin. I think this is when it was created. I think this is the time that it would expire. And this right here would be the signing token, would be the signing key. And now we should be able to manipulate this. We'll send it, and it says we need to authenticate. So what we can do is come back to our terminal, and it says we have this token right here on the login page. So go back to burp. We have the login, we have the bearer, and I had to mess with my authorization here to get this to go through. We now have our JSON key right here with our username and our shared key right here. So now that we have this, we should be able to, now that we have this, we should be able to start enumerating the endpoints of the API, and we can check out. And if you remember over here, where did we run that? Over here, we have all of these different things. And as we enumerate these endpoints, one of the first places we should check is something like users, and we can send this, and it says we get the users back on the box. And because we have this right here, and because we now have control over what is going on, we can go users, and then we could try and see if maybe there is an endpoint with this person. So we can copy this, paste it in, send it, and we now have a password for this user. And we can also go back and maybe see if this person has a password. We can copy it. Guess we don't really need to copy it. I could just type it out and send it. And we have their password as well. And with these usernames, you could go out and try and log in to the actual web page and see if you can figure out how to get remote code execution. But this is the direction of the box. Now, we're not actually trying to get remote code execution. What I wanted to show you was these auth tokens and what you can do with them. So now we're going to come over here to our Portswigger application here, where we have the free labs to practice, and we're going to go all the way to the bottom because that's where these are located. And I think with what I just showed you, you should be able to solve this first lab all on your own. So if you would like to go and give this a try, then you can do that, and if not, we'll go ahead and walk through it. All right, so let's go ahead and read what we are supposed to do. It tells us this lab is a JSON web token based mechanism for handling sessions. Due to implementation flaws, the server doesn't verify the signature of any of the tokens that it receives. To solve the problem, we need to gain access to the admin panel located right here, then delete the user Carlos. So I've gone ahead and clicked access the lab. We can come open this up. We are told we have the good old same username that we have been using, and we can log in. We'll log in just like normal. We can come over to Burp, and we will grab the proxy, and we can refresh this page, and we see our cookie session right here. We'll send this over to Repeater. We can turn that off. And now we can look at this token right here. We have this right here. We have the decoded portion of the cookie, and then we can check this out, and it tells us right here it was issued by Portswigger, and we are signed in as this user. So we'll change this to admin. We can apply changes, and now let's check out see if we can go to the admin panel, and it says, let's see, my account. So it looks like we are able to go to the my account admin. So actually, let's copy this, paste it in right here, delete that, send it. Not found. Follow the redirect. Where does it send us to? It tells us we need to log in. So that did not work. Let's try it again. Let's go my account. It tells us we are still logged in. So let's grab this again right here. We're told that we need to go to the /admin and then instructions. So we'll come back to this, see what we can do with this token. We needed, was it admin, or maybe it was administrator? Like this, we can go to the administrator, sign in. We'll try and sign in as the administrator, apply changes, and now we need to go to the admin directory, and this already looks different. We have the users right here. So if we wanted to delete the user, we could just copy this right here, and I think it should delete him. So if we send this, that does not work. So what we'll do is we'll just grab this entire token right here and we will copy it, come over here, and we'll just put it in place of that one. Forward, turn the interceptor off. It tells us that we have solved the lab, I guess because we had the interceptor on when we sent the request right here to delete Carlos. It didn't refresh the page because the interceptor was on, so it went ahead and deleted the user for us. So that is one way to use these tokens, and they might be a little bit difficult in the beginning, but I really love this interceptor over here that just decodes stuff for you. Otherwise, you can try and decode this stuff by copying it like this, and you can come over to your terminal and you can go echo -n, just like this, and then you would just paste in the token that you wanted to decode, pipe, and then we go base 64-D, and that will decode it for us. You could also just come over to the decoder, paste that in, and decode as base 64, and it'll tell you over here as well. So those are different ways to look at these cookies. I'm actually curious now. This leaves it all as a jumbled mess, but I am curious if the decoder can figure this out. And I accidentally copied it. We'll recopy this, send this over here, and it does get some of it right here. If you didn't know that it was separated by the periods, you could have brought it over here to the decoder and you could figure out what's going on. It's not really that easy to read, but you can see that we got the administrator right here, and we were issued by Portswigger. So, I mean, you could have figured it out. But that is this challenge. There is another one right here that we are going to walk through. So if you would like to open this one up, there is a little more to it. I'm not sure you'll be able to figure this one out completely on your own, but you can go ahead and play around with it and see if you can figure it out. And we'll go ahead and I'll open it up and then we will solve it. I have opened up the lab right here and we are brought to this page. The instructions are pretty much the exact same. We need to make it to this panel. We log in as this person and we delete this user. So we can come over here, go to my account, we'll get logged in, and then we'll intercept the request. Log in. Don't save. It says we are logged in, so we'll go ahead and intercept the request. Send to repeater. We can shut that off. Come over to repeater, and we can do the exact same thing we had just done before. And we're told right here that it's using SHA-256 as the encryption, which I'm guessing is going to be for our session key right here. And so what we can do is come back up here and we can change this to none, and then we can delete our session key, highlight this, and we are supposed to be the administrator this time. We're supposed to be administrator. Learned last time that it is not the admin. We can apply the changes and we'll come back over here and see if we can go admin and we can send this. It says we are unauthorized. Let's try and look at this again. I did not apply the changes right here, so we can say none, apply, send this, and we have made it. And from here we know what we need to do with highlighting this and going over here and trying to delete it. But I want to try this a little different this time. So I want to copy this token and I want to put it in directly myself. and see if I can make it over this direction. Make it over this way. I think it should work. Try this a little different, and it works. So we can come over here and delete the user this way, and you can put the session token in right here. So these are a few different ways you can bypass authentication through tokens and session cookies. You will just have to play around with these as you find them on live programs. They're not always going to be they're just not always going to be really straightforward. So what you could do is look for what uses a period as a separation inside of a cookie or inside of a session token. And these are things you're just going to get used to over time, seeing and not understanding what it is and then looking it up. This is also one reason it would be great for you to read the Web Hacker's Handbook and other web application penetration testing books, or even the Hacktivity, because you're going to see things like this and you'll be like, what is this period? What is going on right here? And as you read, you will learn how to recognize these different things. It's okay if you didn't recognize them this time. I bet you will recognize it the next time you come across it. So with that, we will continue on. Okay, I decided to include this little section right here on attacking WordPress websites because, to my surprise, the more I am in the web application testing world, I am surprised at how many people use WordPress. And even if they don't use it on their main site, there will be subdomains, or sometimes they'll have other domains or subdomains that are also in scope that will have WordPress, especially if they have like a forums or a blog. So WordPress is something that you should be aware of and know how to enumerate and attack it. And so we're going to do a few hack the box WordPress walkthroughs now, just until we get remote code execution or find vulnerable files, so that way you can see how you should attack WordPress. And WordPress is becoming more common, so I decided to include this in here because I don't think a lot of people in the bug bounty world attack WordPress the way a penetration tester would. So we're going to look at these from a penetration tester perspective and how you would go about attacking them, but also along the way you can look for bugs as you enumerate WordPress sites. So let's go ahead and jump into this. All right, I have spun up the box tenant for us to walk through. We're going to be doing two different boxes that have to do with WordPress, and I think this is something that you should really know well, because you're going to see these definitely in CTFs as well as in bug bounty programs. A lot of bug bounty programs, you'll notice, actually will put the blog or some kind of forum sites in the not eligible category or out of scope, which really is a mistake, because a lot of WordPress sites actually do have vulnerabilities in them, and you're going to see them a lot in CTFs. And we're going to cover a couple of those now. So I have already started the server. So we are going to be at IP 10.10.10.10.223, and then we can come here and we're brought to this default page. And one of the things we should always do is try and run FUF or GoBuster. I'm going to use FUF because it is already set up here for me. So we'll just change this to, actually, because this is going to be a WordPress site, we're going to run GoBuster, because we will want to have this extension for the PHP right here. So we can come back here and set this up. 2, 2, 3, and let that run. All right, so I got GoBuster working. It turns out that it wasn't working because I had been disconnected from the box, but now it is up and going, and we see that there is a /WordPress. So we can come up here, type in /WordPress, and see what we come across. We come to this page right here. We can view page source, see what is in here, and there is an href to this tenant.htb. And if you're familiar with Hack the Box, and then you know that you frequently have to add things to your Etsy host file. And the IP address is 10.10.10.223, and it is tenant.htb. Now we should be able to save this and browse out to this page. So tenant.htb. I want to go here, and it loads this page for us. Now, one of the first things you're going to want to do anytime you come to a WordPress page or a blog page in general is just look at these posts here, and you can see you have protagonist as an author, which could possibly be a user. We can look at this one, same user, same author, and we can look here, same author. There is a comment by Neil. You could put this in your back pocket as a potential user, and then it says, did you remove Satyr PHP file from the backup? I'm not really sure why somebody would ever write this right here rather than let the person know elsewhere, but you could try and come in here and type in the satyr.php and see if anything is there. It doesn't look like it, but you could come over to where we know we have this WordPress, and we could say wp-login.php, and you could try and log in with admin or admin administrator. I think you actually can come over here and do an admin.php. Nope. Let's see if it's just /admin. And there is this login page. It tells us it just redirected us here to the login page. So not able to do anything with this. And we'll just come back to that main page. We can come back over here to this. There was no satyr.php, but we could try it over here. And we can run it, and it tells us that it's grabbing users from a text file, which would be interesting. I wonder if you can go users.txt, nothing, and you go back, and it just tells us success. We're not able to actually grab any of those users. So he said it was from a backup file, and often when you see a backup file, it's going to be a .back, and it works for us. So we can save that to our downloads, and we can CD to desktop. We can move. I'm not sure what that saved as. Saved as satyr.back. So we can come over here, move, and then we'll go and we'll move this to the current working directory, which is going to be our desktop. Now, if we ls, we have it right here. We can cat that file out and look to see what's going on. Now, when I saw this, I had to go straight out to Google and look up serialization for PHP because I am not really familiar with it. And when you come out to Google and you just look up serialization for PHP, and then you can just click this top one. And when you look through here, it looks really similar to what we just saw. And then it actually walks us through how this works. So when I saw this, I was like, okay, this must be what is happening. And you're going to have a serialized object. And so you might even be able to go and type in object like this. And let's see what happens if we get it into a JSON. This is Stack Overflow, and you can just look through here. This is what I did to figure this out, remembering that you're going to have to use your Google skills, and this looks even more like what we just saw right here. So we know we're going to have to do something along these lines, and we have it getting a repo, and then it has this unserialized input being called. So what we can do is just grab this right here, and we can make our own serialized object. So we'll do this here. We'll cd into the desktop, and we'll gedit, and we'll call it mine.php. And now we will change this to fit our needs. So instead of going user.text, we'll go pwn.php. We can leave this because this is where this is going to be our object. And then inside the data, we can put in our little reverse shell that we have seen earlier. So we'll grab a PHP. Now we'll do a web shell first, and then we'll do a reverse shell to make sure that it works. For remote code execution, we can just grab this same one we've been using throughout this course. Where did my text file go? Right here, and we can just paste this in. And now instead of, we can delete this extra line here. And up here, we're going to say mine equals new, and then I'll just copy this so I don't have any typo. And this looks like it should work. Let's try it real quick. So we can just say PHP, mine.php, and it tells us we have a syntax error at the CMD. So we'll come back inside here. Okay, and thanks to the magic of video editing and much debugging here, I finally got this to work. I had left in here the public function to update the database, and I had spelled serialize wrong, which took a little while for me to figure out what was wrong. But now we get this output, and this looks really familiar with what we have just went through with our JWT tokens. So now if we copy this string right here and we come back to our page, we should be able to enter it in right here and pull down a web shell. So if you remember from this right here, we have this a repo being called, so we can come over here and we can add this in by deleting the back, add in a parameter, and we can say a repo equals, and then paste in the serialized object that we just made. It tells us that it has added it, and now we should be able to come to our CMD and see if we have code execution on the box. So let's give this a try. Delete all of that and say, what did we name? I think we named it mine.php. So we named it pwn.php. So we can come up here and we can say pwn.php cmd equals who am I, and it tells us we are ww data. So now we should be able to get a reverse shell on this, so we can come back to our reverse shell cheat sheet. Since we know this is running PHP, we can try this with PHP. We can paste this in. My IP address is 10.10.14.7, and we'll go on port 4444, and we'll go bin bash, and we can set up a netcat listener just like this. And we're also going to grab this in burp just in case it doesn't work. We'll send to repeater. We can turn that off. And it doesn't work, so we can come back to burp here. And if we send it, it tells us that it went through really quickly. And it turns out that I am -7, and we send it and we get a callback. So I had my IP address wrong that entire time that I was trying to get that to work. So now I actually want to go back and try my PHP shell and see if that works. Where is my PHP? Come back over here. Paste that in. 1, 2, 3, 4. This is a 7. 14, 10. Grab all of this. URL encode it. Kill this shell. Try a new one. Send. And the PHP one works also. So that was a bit of a workaround, but I think it'll be helpful for you to see one more WordPress box just to see that the enumeration process for WordPress is going to be a little different, and know that you're going to be looking at everything in PHP. So I wanted to show you this one because it just came off of what we saw with a serialized object like this. And I thought it would be helpful for you to see a little bit of code outside of, I thought it would be helpful to see how it would work with WordPress with PHP. And with that, we will go ahead and attack another WordPress box. Okay, so I've gone ahead and ran an nmap scan. And remember, if you run an nmap scan, to do so just on the common ports or the most common ports, because your target, if you're doing a bug bounty hunt, you don't really want to just be banging on their door looking for a bunch of open ports. But if you're doing a penetration test or some kind of CTF, then you can scan all ports. I've scanned all ports here. But just remember, if you're bug bounty hunting, to only scan the common ports, and if you are scanning quite a few ports, maybe slow down the nmap scan. With that said, we have 3 ports open: port 22, which is SSH, port 80, HTTP, and then we have MySQL running on 3306. So the first thing to do is just come out to the HTTP server and see what is here. And it tells us that we have, it says there's an issue tracking until it's set up. We can check out these links right here and see if they take us anywhere. And it tells us right here, it's taking us to spectra.htb. So we probably need to add this to our host file. So we can sudo gedit our Etsy host. And now that that's added, we can try and come back here and see if this will load for us, and go and see if we get anything different this time. And it looks like it's working. I must have spelled it wrong. So it tells us there's an error establishing a connection, a database connection. So that doesn't work. Did we test this one? And we get a WordPress site right here. And this is a basic WordPress site. We are told that it is up to date. It's powered by WordPress. And one of the things to look at is there is a user, which would be administrator, see who commented. And we don't have anything. It just says a WordPress commentator. So there's probably not another user there. We have this right here, this P1. It looks like that could potentially be different users. So you could come up here and just try and enumerate this. It'd be easier to send this over to Burp and try and do this. Now it says we have page IDs. We can look for different pages, but I'm not going to run down this road just yet. While we're on a WordPress page, one of the best things to do really on any kind of page is to fuzz it. So we will do 2 different types of fuzzing. We will fuzz with the extension PHP because we are on a WordPress page. So we can come back over here and it is 229, and we can run this. Actually, I'm not sure that will work because we are on a virtual host. We'll go spe spectra.htb and see if that fuzzes, and it says that that's working. So we have this main, and then also I want to run fuff and see if we can pull down anything else right here on this server. We actually want to run this on spectra.htb, and we've pulled down main and testing. So we can come over here and we can just type in testing, and we are brought to a bunch of files. We've already been to index.php. One of the things you should always check for when you come to a page like this, when you see these config files, config is always a very yummy place to search for vulnerabilities. We can view page source. We know that when we see a blank page that there might be some hidden files, and over here we see we have a database user and we have the database username. Now we saw that on this nmap scan, the MySQL was open, and you could try to log into MySQL, and the way we would go about this is typing in my SQL, and we'll put in the host 10.10.10.229, and then the username was right here, dev test. So we would go dev test, and then we could for our password, and then see what happens. Like this, we can copy, paste, and see if it will let us log in. And it tells us we're not allowed to log in, and it looks like it's because of our IP address here is not allowed to log in, which is fine. You probably have to be running on the local machine to log in. So what we can do is we can actually come back to this page right here, and we see that the admin is allowed to log in. So we have a WP admin. So we can open a new file, type in spectra.htp, come back over here. We can try and log in with the WordPress-admin, and that keeps sending me to, and every time we type in this WP/admin, it keeps sending us to Google. So we're going to turn this off. We're going to come over here and say about config, accept the risk, and we're going to go a keyword. And we're going to set this to false. Now that should be saved. You can close out of it. Now if we come back and we type this in, it should stay on track. WP admin. And it loads for us. Now, if you remember, we saw, I think it was administrator, like this, and then we can grab this password and see if maybe this person is reusing a password. Log in, and it tells us that the administrator email verification, we can just say remind later. We don't need to mess with that. And it allows us to log in, even though it didn't load very pretty. We can try again, and since that's not working, that's fine. The way you're going to see this on CTFs a lot, and you will see this in the future, is to come to the themes right here, and we really need this to load for us. And it loads for us, and now we can come to, while that loads, there is one thing that you should always look to run on WordPress sites, and that is a WP scan. So we can go WP scan, and then we would run -- URL, and then on this box we would run the box name, and the page was main. So this is going to look for the plugins, because sometimes there are vulnerable plugins on these WordPress boxes, especially if they don't update them. So it would look like this: aggressive - enumerate, and then we want all plugins. So if we were to run this, it would look like this. And the reason you would need to run this plugins detection aggressive is because we want it to enumerate all the plugins, not just the ones that it finds in the source code. So if you're ever up against a WordPress box, especially in a CTF, this is something you would want to run. But now that this has loaded, we can come over to our themes and look inside of the PHP code right here inside the 404 template.php, and we can actually add in a reverse shell right here. So we've seen this earlier in the course. We can go php reverse shell, and then we can find PentestMonkey and just grab this entire web shell, or this entire shell, and we can just edit the IP address and the port number. So we'll go to the reverse shell, go raw, Command A, Command C, come back to this spot where we were. We can just paste all of that in, come all the way up to the top, change our IP address to 10.10.14.7, and we'll listen on port 4444. We can update this, make sure we have, see if we can start up a Netcat listener. Listening, and it tells us this right here updated successfully. So we can come back to whatever page that was that we were just on, this one right here. Now if we delete this and we just run this, it should execute that code for us that we just saved. It says that it has updated successfully. Make sure we have the port and IP number right. It is. And we got the reverse shell back over here. So who am I? and we are finally on this box. Sorry for a bit of the workaround, but this is just really the life of doing any kind of hacking. It is going to be a lot of trial and error and fixing mistakes. So this is WordPress. So these were a couple of WordPress boxes. You're going to see WordPress in the future, especially in the world of bug bounty hunting. WordPress is really popular, and this is just a few different ways to go about hacking WordPress sites. So with that, we will continue on. Comes next is usually the question of what kind of programming do I need to know. So in this video, what we're going to cover is the Python that I think you need to know as you're entering into cybersecurity. This is an introductory course into Python for the purpose of cybersecurity. I have tried to keep it as streamlined as possible to keep you away from having to watch a 6-hour course on Python for cybersecurity that is just full of stuff that I think you're not really going to need in the future. So this is a beginner course, and if you have any questions as you're going through it, please leave some questions down in the comments. Decided to go ahead and show you guys how to install PyCharm on your Linux VM. If you have a Mac or Windows, it's really straightforward. You just go to the JetBrains, you download PyCharm. I'll have this link in the description, and you'll click Windows, Mac, or Linux, and then you'll just hit download, and it will automatically start to download unless you're on Linux. So I have had to do this for several virtual machines that I have had. It won't download, and so what you have to do is right click the direct link, and you'll copy link. Then you will go to your terminal and you'll run a wget wherever you want this file to be saved. So if you want its own PyCharm folder, put it in its own PyCharm folder. For me, it is in my downloads. And you can save it wherever you want. You'll hit enter. This might take a little bit depending on your speed, your internet speed. And then you're going to unzip it wherever you downloaded it with this command right here, and then it will unzip. A bunch of files will come out, and then you will be able to CD into the folder. So for me, I will CD into my downloads because that's where it is, and then I'll go into PyCharm, and then I'll ls inside here, and I'll go into my bin, and then this is the executable I want to launch in order to launch PyCharm. So I will type in bash, and then I will type in pycharm.sh, and it will automatically launch PyCharm for me. So this is how you get PyCharm on Linux if you are wanting it on your Linux. I usually write everything on my Mac, and then if I need to run the code over on Linux, I will pull it over to my Linux machine and run it over here. So with that, we will get started in the next section. All right, we are ready to start our Python course. So we're going to start out very simply with a string. A string is a sentence that is a data type. So we're going to have several different data types coming up, but a string looks very simple. It is what I think of as a sentence in English. So you just have hello world. A string is always going to be stored inside of quotations. So if we were to print this, it would print right here, hello world for us. And if we change it, it's going to change along with us. So this is really simply, this is a string, and we can store strings inside variables, which is going to be coming up in the next section. But first, before we go on, you will see sometimes that you need a string on a new line, especially if you're going to export something into a CSV file. You're going to want things on new lines, and at the end of your string you can type something like this and then say hello world number 2, and then we can print this, and we have hello world and hello world number 2. And if I wanted to get rid of that space, I would do it this way. So we have hello world and hello world number 2. Another way to go about printing this would be like this. So print, and then we put our quotations and we say hello, and then we can add this like this, hello world, just like that. And now if we were to print it, we have hello world, hello world number 2, and then hello world. You see how there's no space right here? This is something that I run into regularly, and I just had happen the other day. There's 2 different ways you can put a space right here, and I'm going to show you the easiest way first is just to add a space right there, rerun it, and now you have a space. But I think it's helpful to know more than one way to do this. So you can add another quotation and put a space in there and add another plus sign. So you can run it this way and you still have that space. And it's really important to know this right here, because sometimes you'll be running a for loop and everything is just smashed together and you want a space in there, and you can add spaces simply just by doing this. So what I'm showing you right now, you may be thinking this is not ever going to be helpful, and I wouldn't be showing it to you if this wasn't helpful, and it's something you're going to run into in the future. So this is a very streamlined course, and I'm showing you just what you need to know in the world of cybersecurity. Now we're going to be covering something called a variable, and a variable holds the place of some kind of data that we're going to want to use later. So we'll go ahead and comment this out, and on a Mac it is command and then question mark. And so we'll comment that out. So now if we run our program, there's no output. And we're going to look at a variable. So a variable can be something like this: name, and then the name Jim. This name is going to hold whatever is right here. So this is our variable, which is going to represent the name Jim. So if we come down here and we print, and then we type in name, and then we run this, it's going to print what is stored inside this variable. When we look at variables, one of the things you're going to want to be able to do, especially in the world of cybersecurity, if you ever want to write your own tool, is you're going to be saving variables, only they're going to be input variables. So if we were to go like this and we say name equals input, and then we type what is your name, and then we'll want a space right here. So when we type in the prompt, it has a space. We'll comment this out, and then we'll print name. So we're going to print the variable, whatever the user inputs here. So now we can say, what is your name? And we can say Tom. And when we hit enter, it prints Tom. And there's something else that's really cool that I use all the time. It's called an F string. And what you do is you add an F at the beginning of your string, but you can print variables inside your string. So we'll go ahead and put name inside here. And so we can say hello, and then the name. So we'll say run this. What is your name? Tim. And it puts out hello Tim. So this is an F string. This is something you're going to want to know. This is something I use all the time. And in the next coming up videos, we're going to look at data types and how we can pull information out of a specific string. And this becomes really useful whenever you run a script on a victim machine or on your target machine or your target server. You may get a lot of output that you don't really need, and this is a good way to start extracting data. So we'll start that here in just a moment. Okay, it is time to draw out some information from our string. So what we can do here is we can save a variable, and we'll call this variable name, and we can put inside of our name Tommy. So we have Tommy here, and let's say we want to grab just this M right here. What we can do with this is we can say print. We want to print our name, and then we add some square brackets just like this. And when you're running Python, it always starts at 0. So it goes 0, 1, 2. And so that first M is going to be 2, just like this. And so if we run this, it's going to print that M for us. And just to show you, if we want to print the T, we would enter a 0 here. And this is one of the most basic ways to draw out information. And it's going to get a lot more complex as we go, but this is what the square brackets do when you see them. And when we start to tackle lists and arrays, these square brackets become a really useful tool to remember. So as we continue to go through this, I want to pause right here and I want you to go ahead and play around in your own text editor and make some print statements, make them on new lines, add in some spaces, make some inputs, and actually practice gathering information. And maybe have 2 or 3 inputs and have it print things back and forth, and you have a little conversation with your text editor. So I want to go ahead and give you this challenge for you to go ahead and play around with the things you've learned so far and try and really ingrain this information into your mind. These are the foundations of Python programming, and you need to know and understand how they work. You're going to notice is you can name variables whatever you want. And I name my variables really poorly, mostly because the programs I write for myself, and I am not working with a team of developers, but maybe you will someday. And when you name your variables, you can name them whatever you want. And you'll want to make them names so other people can understand what is going on. So if you look at some of the code I've written in past videos, I do this right here. I name everything like this. And it is not really the best way to go about naming these. So I'll name one guy 1, and I'll go guy 2, and he'll equal Bob, and then I'll come down here and I'll print guy 2. And then I run this, and then I have Tim and Bob. You can name variables whatever you want. Literally, you can go whatever I want. And you can make this a variable, and then you can come down here and you can print whatever you want right there. And you can name variables whatever you want. So I would recommend getting in a good habit of making your variables something that you can recognize. And it's a very bad habit that I have, because I make my variables so that people cannot read what I have done. So this is something I'm trying to get better at, but I probably won't, because this is a bad habit that has formed over many years. But I want you to have a good habit of naming your variables something that you can understand and other people can understand. So as you go through and work through your challenge, try to name your variables different things that you will be able to understand in